All right, good morning, good afternoon, and good evening, everybody. Welcome on into the Dragon's Den. My name is Digital Dragon, aka Luke, and I'm a 3D printing variety streamer here on Twitch. Some of you might ask what that means. Well, that means that we do everything from printer assemblies to modifications to full up printer builds like all the ones you see behind me. I also take part in various prototyping efforts. So we've got a zero G Mercury 1 right here in the middle that was built during a closed beta, the full frame up build. Actually, I had to drill and tap the frame myself. Excuse me. We also took part in a Trad Rack closed beta and the Beta Strop Effect Next G betas. Yeah, we do all kinds of things, cosplay and various other. Excuse me, folks. Oh, I apologize. We're going to fight with that all stream. I went out this morning and got my initial power up and quickly realized that we have now entered pollen season here in North Carolina. Some people call that spring. We call it pollen season out here. And yeah, allergies. Oh, goodness gracious. But yeah, welcome on in, everybody. Timor, welcome in. Shadell, Robert. Yeah, so I'm going to be dealing with some allergy stuff here as we go through this morning. Just please bear with me. It should die down after a little bit, and if it doesn't within the first hour here, I'll go down and take some Benadryl. But yeah, hey Pez Liz, welcome on in. Oh, geez, I am so sorry there. Yeah, I noticed it was going to be bad because when I was heading into, I'll say into town to go get Dunkin', we had these trees, and the closest thing I can say is, if you've ever seen cherry blossoms in full bloom, I know these aren't cherry blossoms, but it reminds me so much of it. You know, big yellow and white flowers, primarily the white and the pink or lavender ones, everywhere. These are huge trees, and they throw pollen everywhere. One of the guys has this big grazing field that I drive past, and you see all the sea of blue starting to come out where the wildflowers are starting to bloom, and it's going to drive my allergies batty. So thinking future streams, I may not go out and do a Dunkin' run. Uh, Struggle stay at the house. Sounds good, Pez Liz. If you get tired of doing housework at your place, you're more than welcome to come over and do some housework at mine. Just let you know. Um, yeah. Good morning. Good morning. Good morning. So today we're going to continue our journey on the black box, and we're going into section 4 of the manual, which is the XY motions. Today's going to be fun and interesting. We're going to get into some of our CNC machined aluminum parts. We're going to be breaking out the epoxy, um, some more rails. So we're going to have some more lubricated uh, sticks and balls. Um, Not to mention plenty of little shafts, some big shafts, some all kinds of things. Good morning, Creatix Britt. How are you doing today? Hope you're doing well. Oh yeah, we also get to play with some motors today. So we've got all kinds of great things in this particular stream. So welcome in everybody. You may see me sit down a little bit later because I have a feeling that this is going to be a long stream, and I'm not sure if we're even going to get it done today because this is a pretty long section. Yeah, it's a party in here. We're gonna. What was that shirt I wanted to make? Coffee and lube. Yeah, we need a coffee and lube shirt. Hey, Build Over Bot, welcome on in. Welcome on in. Thanks for being here. So For those of you that are just joining in, please bear with me a little bit this morning. I went out to get my Dunkin' this morning, and it's obvious that North Carolina has moved into what some people call spring. Down here we call it pollen season, and it's just we've got full, and I'm talking full, massive, like mature trees that have all of a sudden it feels like overnight blossomed with flowers everywhere. And some of the fields around here, you look over them and it's just like, like the Sound of Music meadow with the blue sea going through it with all the wildflowers starting to kick up, which means pollen's in the air. I've got pine trees all around my backyard, so bear with me. I will have to remember that and not go out for coffee next weekend. But let me go ahead and switch over here. You'll see we got the workbench cleared off some. But I do want to say, and let me see if I can grab this and bring it over here. For those of you that have been following along on the other project that we've been working on, look what we got down here. Once again, underneath the desk, because it's out of the way. There's the trident, and I cut some extrusions. Now this is extrusion off Amazon. So I had to tap and use 6mm bolts here. But yes, the Enraged Rabbit carrot feeder is mounted now up on the trident, so it's at least a little bit easier to work around. Um, so I am East Coast, so it is 10:08 a.m. here on the East Coast of the United States. And so I changed my interface slightly. So now I've got to go and play with a couple around on. Because normally all the way on the right hand side, I have the chat window, and I moved it more on the left side of the right monitor. So here we go. This is kind of my setup here. Normally chat was over here and I didn't have the activity feed at all. This was one bigger window. So on the left. So chat over here, main OBS window, and then I got the activity feed. And then over here is where we've got the Blackbox page up. So if we need to look at the CAD for anything, we can. And then we've also got the instructions that we're going to be going through. So yeah, just a little sneak peek, and then of course project mess. We're using Blackbox as the horizontal surface too today. But yeah, so a couple of the new tools that we're going to be using today, like I said, we're going to be breaking out some epoxy very early in the stream. So of course we've got a little dish to mix our epoxy in, the stick that we're going to use, and what I'm going to do is I'm going to cut off one of these ends, and because you don't need this big a stick. These are the just standard wooden skewers, and I like using these because it gives me a wider end that I can stir the epoxy with, and then I have a tip that I can use to apply the epoxy if I need to, and that's going to come in handy today. An electric drill, a hand tap wrench, some hex wrenches, some taps. We're going to need some taps. Ooh. I'll have to double check and make sure I have the 0.5mm 5 tap. Reamers, thread locker, of course, soldering iron, tweezers. This is where you start realizing that this section is going to be a long section. When you look at the parts that you're going to use, and you realize, T-nuts and things like that. But then you've got your linear rail, some neodymium magnets, 3 motors, the black stops, the CNC plate, some bearing flanged bearings, various pulleys, various linear shafts, um, belt clamps. When you start looking at this big long list, you start going, "Oh, this is going to be a long section." You also realize there's 174 pages in this. And printed parts, of course, another litany of parts. Hey, Royal Nomi, welcome on in. We're just kind of getting started. We're a little bit of a slow start today, partly because my allergies went nuts because I went outside and we started pollen season. In Warzone, you asked me what time zone I'm in. What time zone are you in, my friend? Actually, let me. Yeah, East Coast is New York time zone. Yep, yep. So just some prep stuff. Let's look through this. So for the XY motion section, the installation tools and the alignment jigs may be printed in a less expensive material like PLA. Yes, printed these out in PLA. Oh, you're UK? Okay. So it's later in the day there. Nice. Yep. No, I can do military time. I'm retired Air Force. Your kit comes with an SLS printed extruder drive modified set screw. I believe, where'd I put that? Oh, I'd already gotten it out. That would be this piece right here. This is part of our locking motions and the extruder system. Um, Model print extruder drive is provided if you need to print your own extruder drive gear in the future. If you do choose to print the extruder drive gear, it must be printed with a .02 nozzle and with specialized bearing filaments. Highest eye glide. Okay, well that's good. We'll be securing your MGN12 cartridges to the Y-axis linear rails of the frame on the X gantry. You will also This will also involve the installation of the remaining linear rail for the X gantry. Both instances, be careful. The rails can slide off, and then you drop your balls everywhere and mess. Use some blue painter's tape if needed to keep your cartridges. Best to lay out all the hardware to identify each step. Yep, stay organized, stay clean. Things will go well. Lengths of the hardware are not substitutable, and a shorter length will prevent proper hold strength, while a longer length will deform the 2010 or 2020 profile. Be cognizant. And we're going to get into our Kelvin X carriage plate. So that would be this plate right here. I like that these are very well packaged in um, laser cut cardboard and shrink wrapped here, or wrapped with some saran wrap type material. And these two little clips here are your belt clips. So remember that. Don't lose them. So lasered, cut out the cardboard with the Blackbox logo. Pretty neat. Um, yeah. And then the back's got a nice sheen of oil on it. Oh, same thing on the front, which is good, by the way, because it keeps it from getting any type of corrosion. It keeps it nice and clean. But we're going to need a clean surface because we are going to be um, using some epoxy on this, so we are definitely going to have to clean this up before we do any epoxy. The epoxy that we will be using is provided in the kit, and it's Bob Smith Industries Quick Cure 5-minute epoxy. Takes about 5 minutes to set up, and then 15 minutes to a full cure. Commonly used in what am I thinking of? Commonly used in RC modeling. So I was saying if that was oil. I don't think it was oil. I think it was just left over from the cutting process. But either way, you do need to get in here and make sure it's nice and clean so that you can do your epoxy process. Now, I do want to say you can tell the swirl marks and you can tell the step over. So um, you can see kind of a line right along this low, what, yeah, you can see a line right along here. That's where the step over was in the facing movement bit. So pretty nice. Might be easier to see on this. But yeah, very, very nicely machined parts here. And what I'm actually going to do is I'm going to set this back in here now that we cleaned it off and wiped it down. So that when we go through kind of reading ahead, what we're going to do is using a disposable toothpick, place some epoxy into the machine pockets of the X plate where the 3x8mm shafts are going to go. So you'll see a picture down here of where we're going to put these shafts. We're going to have 3 on one side and then 2 horizontal ones on the other. We want to put a small dab of epoxy in each of the end areas. So 3 over here and then 4 over here. And then we're going to gently set the M3 by 8mm linear shafts in there. And these these linear shafts will then provide a kind of a self-aligning piece that will enable, when we pick tools up, it will enable them to align properly. It's gracious. How do these end caps come off? And hey, shenanigans, welcome on in. Or how the end caps come off of this darn thing. Because this is a weird type of end cap. We wind up breaking into this darn thing. Because the end cap, the stopper itself isn't like a rubber plop-in stopper. This goes on the outside of the tube. Oh, there we go. It came out in 2, 4. I need a total of 5. There's the 5th one. Luckily, the 5th one, when it popped off, landed on my thing there. So I hope there were 5. If there was 6 or 7, then I'll be looking for it in the carpet later. Luckily, these were the 3x8s, which are a little bit bigger than the 2x6s I think we'll use later on. Probably should have counted those. We have an ad getting ready to start. For those of you that are not subscribing, I apologize, but it is a way that we help to keep the channel going. So locate the plate, which we have here, and the 5 pieces of linear shaft 3x8, which we have here now. We're going to mix your aluminum to steel epoxy according to the manufacturer's instructions using a disposable toothpick. Place some epoxy into the machine pockets where the shafts are to be placed. It is best to place a bead approximately 2 millimeters at each inside corner where the shaft will rest. That's why I said we're going to do each little corner in our piece. So where it's got the machined out corner there, that's where we're going to put a little bit of epoxy. We don't want it in the middle. Okay. And when we go to put our shafts in, we don't want to rotate the shaft in the pocket. We want to place it and leave it. Okay. Because you want the epoxy to be between this aluminum surface and the steel shaft, not on the top, because then it can impact um, the actual movements. So we want the epoxy at the bottom between the two metal parts. So insert the shafts. Center each linear shaft in its pocket using tweezers. It's best not to rotate the linear shafts after they encounter the epoxy. Only parts of the linear shaft that meet the X plate should be in contact with the. So that is very critical here, because once again, what we're going to wind up doing, I'll scroll forward and show you this. We're going to place the epoxy. We're going to place the shafts in here. And then to ensure the proper positioning while the epoxy dries, we're going to place a steel bearing ball, which is an 8 millimeter G10 ball, in each set of kinematic points, and then place something on it to apply pressure down. Okay, so the end result is it's going to be sitting here like this with these balls. Now, I did some running around this morning because the linear balls are not in the base kit. The linear balls are in your FDM toolkit. And what we don't notice is until the end. So I took a note for Kris to make sure to call that out where we identify um, the balls here, to add another note that says um, steel bearing ball 8 millimeter G10 can be found in the FDM toolkit. Okay, because if you order all of your stuff at the same time, you're going to need at least one of these per toolkit. I ordered these separate because I was paying for these where Kris provided the base kit, and therefore it wasn't in the box with all the other parts that got sent. But when you get this, it comes with various parts like your gearing, some silicone wipes, the uh, Delrin, I think it's Delrin or HDPE locking block, um, as well as various other things here to include some shafts and magnets. There's your 2 balls right there. That's the other thing you need. Now, this is another one of those caps that was a pain in the butt to get off. So, I kind of want to open this. No, that's not. Well, I got a big one. I kind of want to open this in a big bag or something. So if it goes anywhere, it preferably does not go shooting around the room. Oh, here we go. Things don't go shooting around the room, but I'm going to drop these things out to get to those balls, and we'll throw everything back in there. Now we've got our steel balls. So I think we have everything now that we can start mixing up some epoxy and getting these put in. We understand the process now. Grab our tweezers and just check and make sure that your tweezer ends aren't all bust or all bent up and everything. Sorry, this over here. Done. Um, Once again, look at the instructions on your epoxy that you have. They do provide epoxy in the kit. This is Bob Smith Industries. I've used this a lot. This is very good stuff. In fact, there's a good chance that I have some of this somewhere around the house from my modeling days and possibly from the airplane build. There's also a good chance that it might be 30-minute or something stronger. And you want to double check. So if you do go to use something different, right? One, they provide this. So I would highly suggest using this. If you go, oh, well, I have some epoxy already. I don't want to open these. I'm just going to use my others. And it happens to be, say, mid-cure or 30-minute epoxy. Um, Note that on the back here, you've got the different types of adhesives that they sell, whether it's epoxy or um, super glue. And you'll notice that the reason we're using the quick cure is because it's got the best hold for metal, where the medium cure is good and the slow cure, which is the like longer cure, is also very good. So just be mindful and look to make sure if you do deviate or you decide to use your own, that it's good and suited for the purpose that we're going to be using it. And what was that? Texas Leo, thank you for the follow. Thank you for the follow and welcome in. Hey, Hybrid Robotics, welcome in. So we're just kind of going through. Now, what I'm going to do is I don't need this full stick, and the big stick is going to become unwieldy. So I'm just going to take a pair of snips or anything and cut the end off. And the reason you want to do it with a pair of snips rather than break it is if you break it, I mean, these are relatively cheap skewers. If you break it, you're going to get some shredding out. It's not going to break cleanly like that, what I just did. Now I want to use this end to mix the epoxy up and then this end to apply the epoxy. Okay. And then you can take the rest here and put it aside for later mixing sections, like when you're doing droid builds. Now, on our two-part epoxy, you also want to look at how these get mixed. So clean and dry the surface thoroughly. We did that with some isopropyl alcohol. Remove the cap, snip off the very end of the nozzle, and squeeze equal amounts by weight or volume of 5-minute resin and the hardener. That's the other thing you need to know is what is the ratio? A lot of the smaller kits like this, and if you were watching with the droid build, you saw that I actually had the one that has the dual plunger, and that helps make sure that you get an equal amount. But like some epoxy resins, when you're dealing with like fiberglass or carbon fiber layups, they're not a one-to-one. So you really need to pay attention and understand your epoxy systems and figure out how the ratios of the mixture. Hey, JD Montgomery, welcome on in. Hello. The other thing is, and I'm surprised it doesn't have it here, um, color code your caps. The last thing you want to do is take a cap that is for your resin that may have residue on it, put it on your hardener, and now the fumes from the hardener is going to cure it, and you're not going to get that cap back off. So the hardener is the red, which matches. The resin has a black face, full black face to it. So I will Sharpie this to make it black here in a little bit. And once again, we're going to snip off the very end. Use a pair of pliers or snips, whatever, just to snip off the end so you get an end. I'm going to keep these kind of separated a little bit. And then what I'm going to do, not going to put them side by side just yet. I'm going to put out a little bit of the resin onto just a little dish. These are lids of like serving trays. And then pop the plugs out. Careful, use your finger to raise up the plug and then pop it out. Now I just had tried to push stuff through this so there is resin all over the bottom of this plug. So be cognizant of that and make sure you wipe your fingers off. Once again, no need to glue yourself to anything this early in the game. So we are using the epoxy. So here, let me bring up the picture. We're using the epoxy to epoxy in these 5 M3x8 shafts on the kinematic plate. So what that will do is there will be 2 8mm GT10 balls on each of your tool heads. And that's going to allow the precise precision or the positioning when you pick up a tool head, but also give you just the tiniest bit of wiggle room through that process when you're picking up your tool head. So we're going to use the epoxy to epoxy in these shafts so they don't move off the kinematic plate. Dang it. This one's kind of being a pain in the butt. There we go. That one's out now. And I just got it all on my fingers, so let's clean that off. The hardener by itself, the resin by itself. Neither one's going to quote unquote stick, but once you mix them, then you're having a chemical reaction. And that's what your epoxy is a chemical reaction. And we're also not going to use a lot of this, so we don't need to like make a super duper huge amount here yet. We're just doing small dabs. Knowing as well that the process of mixing, we're going to lose some epoxy to the stick. Once again, we're just kind of going by size of our blobs. You can go by weight, you can go by volume. And now we're going to take this and make sure that we get it thoroughly mixed between these 2 blobs. You want to move things from the outside to the inside and make sure that you get this thoroughly mixed. We're going to need about 20 seconds or so of mixing. When you see me coming from the outside in, I'm rolling the stick and that's scraping it and rolling it up so that I'm mixing from the outside in. And like I said, we're going to use a very small amount of this, but it becomes harder if you try and say, oh, well, I'm not going to use a whole lot of this. I'm just going to mix up a very, very small amount. It's really hard to get it mixed properly. You may have saw how at first it was getting like a color to it, almost like a yellowish color, and it looked like you were getting a lot of air bubbles in it. But as it starts to mix and that reaction starts taking place, that goes away. I'm going to try and scrape off as much of that as possible so I don't get it on myself. Flip the end around, and we're going to take the pointy end, get some epoxy on it, and scrape it off, like I said, right in the corner pieces of our part. Once again, a little glob of epoxy, and we're going to drop it right in the corner of our part. Now this is 5-minute epoxy, but there's no need to rush here. If you rush, you're going to make a mess, and you're going to have to clean some stuff up, or you're going to epoxy your balls in, and that would be bad at this point if you epoxy your balls in. And by balls, I am talking about the ball bearings. We just want to epoxy the ends of our M3x8 linear shafts. We don't want to epoxy the middle part. We don't want to epoxy the ball bearings in. We're just doing the linear shafts. Making sure and getting some epoxy down in the corner recesses of each area, but we don't want to have it like hugely globbed up there. Otherwise, when we go to stick our shafts in there, we're going to get stuff everywhere. So we're going to take these shafts with our tweezers, gently drop them in place. We don't want to roll them. We just want to drop these in place, because if you roll them, you're going to get that epoxy on the shaft. And we don't want the epoxy to be on the top side of the shafts. We want it to be on the bottom side of the shaft. Not, oh, a lot easier to say, a little bit harder to do. Okay. Darn it, I wanted to double check something. Yeah. So isopropyl alcohol and acetone can be used to clean up before it cures. So what I'm going to do is take some IPA and make sure and clean any of the surfaces that have uncured epoxy sticking out. So anything on the face that I kind of made a mess of when I was doing this, I want to clean up now while I can. And if things kind of popped out of place like this one here, grab it and reseat it. Moving out of place, do that. Make sure that they're down there. We need our two balls. So two balls, we're going to just sit right in the middle. And then we need to apply a weight to them. What I'm going to do is I'm going to take the beacon box here. And a 3 block. Not going to stay balanced. I don't think just the 1, 2, 3 block will. Nope. I do want to apply some type of weight here, but I'm not going to. Got a book, and I don't want to really put a book on there. Move that epoxy aside for right now. And I'm going to take a Sharpie once again and mark that one lid. May come off, but at least I will have a mark on it, and if I need to, I can mark it in. Black, black, red. Well, I wanted to do something to apply some weight to it, but not going to apply even weight. Do like that, and we'll scoot that off to the side. We'll let that epoxy cure. We're going to let this epoxy cure too, and then we'll throw that away. Let it cure on its own. Same with that. These were just. So we've got our kinematic plate going. We've got the balls on top of it, and we've got a plastic container with some weight on it that's going to help hold those shafts in place. These aren't needed again until we do it a lot later, but we do this early in the process to give that time to cure. Hey, Zombie, welcome on in. Let's see who else we see. Hey, Texas Leo, welcome in. Britt, welcome in. Texas Leo is your buddy from TikTok. He makes 3DP content and is retired Air Force. Well, awesome. I'm also retired Air Force, Texas Leo. Welcome in. Welcome in. Glad to have you here. Um, well, thanks for sharing the love, Britt. And like I said, welcome on in, Texas Leo. Zombie, welcome on in. Good morning. Hope you're doing well. So Zombie will be also building a black box build. So he's kind of trolling me to figure out all the things that I do wrong, so he doesn't do them when he gets his kit, starts his. But Zombie is also working on the what are they calling it? It's still the tap changer, right? Boron tap changer. It's not a Boron. How do I put this? It's not a Voron sanctioned mod, but it is a mod to Voron printers. Primarily, it works on just the 2.4, and you get the best bang for your buck on doing a 2.4 to 350 size. But there's also the mist changer that's being designed by another person as well. There's a couple of options there if you're going to be doing a build. Now, as further part of our preparatory steps, we're going to take our last extrusion, which is another one of the 10 by 20 extrusions here. And this is going to be the X gantry. We're going to need this, and we're going to need our other MGN12 rail. Now, there is no need to pack these. They are already packed, and they are well oiled for shipping. Um, yeah, they are well oiled. You got to open this, maybe have some gloves, and if you don't have gloves ready, at least have some paper towels so that you can start wiping them down and getting some of the excess shipping oil. Make sure you don't slide your carriages off. That's bad. We'll need 820 series M3 nuts. And so once again, the difference is so both of these are M3 nuts, right? So M3 is just the size of the threading in your T-nut. The difference is the black one is the one for the standard 2020 that we use. Silver one is an M3 that's used for the 4040 extrusion that we've used for the frame rails. So as you can see, standard and the 4040 side. So this is a chunky beast. This is a chunky beast. Hey, Everything Plus Ultra, how are you doing? You're doing good. So we need 8 of our 20 series. And I tend to do 4 in opposite directions. So 4 facing one side, 4 facing the other. We are going to just put these in place and we will align them with the rail here in a little bit once we get ready to go. So we've got those in there, and I'm just going to break out some paper towels so that you all can see this better because, you know, black on black on black kind of isn't easy to see. So we've got our peanuts in here. Make sure that they are in there right. They clip in. And once again, we're going to open this up. Make sure you have some paper towels on hand and or you've got gloves on, because once again, these are packed with a good deal of shipping oil. And I will score this on the back. I find that that has been the easiest way to get into these. Form on the back. The carriage is down at this end, so I will split this apart down at this end. Kind of open it like a popsicle. And that way, while I'm holding the carriage, I can wipe down the front and back of this, the sides. Whoops, that was interesting. I'm gonna get the carriage. Once again, we're being careful once we get those little O-ring rubber band grommet things off, that we keep the carriage on the rail, but that we're getting everything wiped down, because there is a plethora of shipping grease. Now we're just going to set this down and bring our rail right next to it so we can line up our M3 peanuts. Mostly. We'll get them mostly lined up right now. And then we'll be able to get them fully lined up. Once we put this on. And we're not looking for perfection right now. All we're looking for is to get these lined up and get our M3x8s started. And yeah, black on black on black makes it so much more fun to get these started. M3x8s, socket heads. When you see me kind of step off screen back here, I'm actually over here digging out some screws and nuts. So just getting a few on hand here. And I'm going to double check and re-verify. So we've got our peanuts laid out. Okay, so lay out the T-nuts. Then it wants us to, the printed blocks. So we've got our 3 printed blocks here that we're going to use to align things. And we're also going to have an end block that we'll use as well. Place the remaining linear rail on top of the extrusion. And this is going to help us get aligned. What I normally do before I put those on is I go in and get all of my screws started, but I just get them started. What I'm looking for is to just make sure that they're M3x8 socket head. Hey, K2 Kevin, welcome on in. Welcome on in. Stephen Poole, welcome on in. Sorry, let me scroll back up here and catch everybody that just popped in the chat. Yeah, how are you doing today, Hybrid? Doing well. Everything Plus Ultra, welcome in. Good to see you. Processing the giveaways this morning. Good. Hey, Liz, I know I had won a spool of filament, and I heard something about it being a special spool, but I have no idea what spool I got. I was just thinking about that this morning. as well as over there dropping the cute squirrel butts. Glad you're doing good. Everything plus ultra. I'm not sure what happened to you, but glad you're doing well as well. So right now I've got four. There's you can have five. I've got four FDM tool heads um, purchased for this, and I think I'm waiting for some more parts to be shipped that were I thought being shipped yesterday, but I don't have a ship notice yet. There was some of the lineal harnesses for the tool heads were on back order. I think he got those in on Fridays. Should have shipping and all the tool, the remaining tool. Uh, but I'll go over the four tool heads I'm building in a second here. They're just getting caught up. Okay, it's Capricorn. Okay, great, Pez, thanks. The sparkly purple. Ooh, well, good. That's what I was hoping for. And that was it. The ambrosia midnight something that you were showing off, zombie. That looked amazing. I need to get me like several of those spools. I like Galaxy ASA Blue. Nice. Awesome. So let's get these started. Um, Once again, you're going to have to slide this back and forth, and that's another reason why I don't bother putting those on just yet, because I'm just getting my um, screws lined up, and I'm not putting any tension on the rail yet. We're just the whole purpose we're trying to do right now is just to make sure that we get our peanuts lined up appropriately. But yeah, thank you to everybody that is following and the new follows. It's greatly appreciated. So I was sitting on Aaron's stream last night, watching him rebuild his trident, which, by the way, is looking awesome. And every time I see somebody do a reverse um, layout on the electronics, I just it makes me it makes my heart sing when I see it because that's how you do the electronics on a 0G, and it works so well. And I have yet to do it on one of my actual tridents. And as I was sitting on the floor right here with the trident on its side, and I was trying to, what I did, where's the extra printed part at? What I do with it? What I do with it? Darn it! Here it is. So I printed one of these out, and this fits into this one of the skirt openings, and I'll have a little locking piece that goes on the back that locks it in place. But what this allows you, this one is for a 2x2, so 2 pins on top, 2 pins on bottom. And I realized I don't have any of those female connectors, but the IRCFA kit came with plenty of female and male microfit 4 pins, like straight in a row like this. So I reprinted this piece with a 4 pin straight in a row. So what I did was I've got the female connector that presses in from the back, and I did my pin out for the um for the CAN bus cable that goes all the way to the top for the MMB board. And then did the, I guess that's the male that goes in there, and then these are the female connectors, locking connectors. So I created this. So it's the reds for power, ground, and then the CAN bus high low over on the next two. And so this way it'll allow me to connect in my CAN bus to the ERCFA. And then if I ever need to do maintenance or take the ERCFA off, I can undo the cable for both sides and I don't have the cable in the way. This makes it a little bit easier for maintenance. But yeah, I was sitting down on the floor trying to do cables, right at, in a gap that was like that big. And it brought me back to my 0G days and going, why didn't I have this where it's all there, it's all easily accessible without having to flip the printer up and over. And so that may be something that I do later on other builds. Yeah. Hey, Major Gamer Geek, welcome on in and thank you for resubscribing for 7 months. Dude, awesome. Yeah, you were killed for over 100 meg per second. Yeah, at my old house, I had gigabit Ethernet, or excuse me, gigabit fiber, and it was symmetrical. So it was gig up and gig down. So that was awesome. Now where I'm at, I'm more rural, and they're starting to pull gig fiber into the town of Sanford, but I'm outside the city limits. So God only knows what'll happen to me. Okay, so we've got all of our screws in. We've got mobility left and right. We've got our alignment blocks that's going to align our rail on the 1020. Oh yeah, morning hype. Thank you for 101 biddies, Pez. I appreciate it. I appreciate that. Welcome on in, Mini Bice. Welcome on in. So the agenda for today is the XY motion system of Blackbox. And you see everything that we've been working on. We've got our X gantry and the linear rail. And what you don't see over here, because I'm leaving it to let it dry, is we've been working on the kinematic front plate for the X gantry. Yeah, exactly, Build Over Bot. Hey, Hobby Main, welcome in. Ooh, eating pancakes. That would be so awesome. I got to be careful about eating like breads and pancakes and stuff like that. I've got some high protein ones that I'm going to give a shot to, but I have found my gluten tolerance is kind of iffy these days. And we are close to getting a hype train started between Major Gamer Geeks resub and Pez's 101 bits. If we get another sub or bits here in the next few minutes, we will get a hype train started. The city couldn't handle you, Bob. That is probably true. So we've got it laid out this way. We've got access to all the holes, and our carriage will move around some if need be anyhow. And with everything loosely lined up, blah, 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 we're going to have a end block here. And this is going to set the specific distance that we need. There you go, 56.5 millimeters. So I like that our tools have the name that's being used and the distance. And there we go. We got a level 1 hype train started. Awesome. Thank you, Zombie, for 100 bit with the pride symbol. I appreciate that. So we're going to use this, and it's going to go on the right-hand side. So we're just going to kind of follow that guidance. We're going to put this on the side, and we're going to take our rail and pushing everything tight. We're going to move our rail down so it touches. And then making sure we're going to start here in the middle and tighten these down. Now, I go through and just snug things, going middle out. And K2 Kevin with 102 bits. Thank you, my friend. Thank you, friendos, for keeping the hype going. And like I said, we're just going to work our way from the inside to the outside, making sure that we're keeping our distance here and our blocks are being utilized to keep our linear rail centered. Now that everything has an initial tighten to it, we're going to come back and we're going to apply a little bit of ugga-duggas. Remembering we don't want to torque these down too much or we will deform our gantry. Okay. So we just want to check and make sure. I'm going to put my finger here at the end stop. We have good movement through the whole linear motion. So that's good. We've tightened all of them. Remember not to over tighten to prevent damage to the slot profile. Now it says to apply some blue painter's tape to keep this from sliding off. Or if you have some and they are the right size, and I've thrown a lot of mine away, take your little rubber grommets and use your rubber grommets in your empty holes, and that will keep it from sliding off the ends of the rails. And these parts can go away. So I've been keeping all of my used tool parts in case I have to do some maintenance or rework. So thank you for the hype train and thank you for showing some love to the channel. Once again, all bits and subs go right back into the channel, either to buy equipment for the channel or to buy new builds and to help offset the cost of all of these builds. So if you like what you see and you want to see more builds, please by all means continue to give bits and subs to the channel. Because that's what keeps me going, helps me show up at shows and continue to bring these things to you all. Thank you for 10 more bits there, Pezlas. I appreciate it. So once again, I'm just going to take this, scooch it to the side. Actually, I'm going to scooch it right there. I'm going to take this and move it off to the side, because now we're going to get into an interesting part of the show, and this is where we start doing some tapping. So we're going to do some tapping. Hey, Kris, welcome on in. Thank you for the 100 bits. Mr. Wizix, thank you for the 100 bits. Awesome. We've got some bits and subs coming in, so that's great. Kris, one thing I did take a note on is when we're doing the kinematic plate here, right? It talks about lining everything up and being careful. We used some isopropyl alcohol to wipe off any excess epoxy that we had on the front side of the plate, just to get it off. But when it talks about placing the steel ball bearings here, the 8mm GT10, there's no note of where those are at. The closest thing you get to a note is, you place a book on it, let it until it's fully cured. We're not intending to epoxy the steel bearings to the 3x8 linear shafts, just the shafts themselves. Is way down here where it says, after the epoxy is fully cured, remove the ball bearings. These are not needed again until assembling the FDM tool. So what I said was to add a note up here, um, that the ball bearings are actually in the FDM toolkits. Because otherwise we don't know. Like I spent like 30 minutes rummaging around trying to figure out where those are. And then it dawned on me, hey, look in the ball bearing toolkits. That might be where they're at. So I made a note to add that to the manual. The other thing, from just a grammatical thing, rather than running in the notes in line like this, drop them down and add them down here and maybe put them in bold. So they're easier, they pop out, they're easier to see and find. So just a couple of things that we've been noting. That part. Now we're going to get started here. And now we're going to need to go through and do several different small pieces here. And when we do these pieces, we're going to be tapping them with M3 threads, just like we did before. So we're going to go through and we'll grab these as we need them. But hopefully you have a tap set. If not, KB3D does sell tap sets. So I would suggest getting some tap sets from KB3D. I'm going to be breaking out my Pittsburgh Tools one. Now I did order an M5 Ultra Ultra Fine, which is an M5.05 thread pitch, because I wasn't sure if this set actually was an M505. It's a 305, and then my 5 is a, I can't read. Yeah, my M5 tap is a 0.08 thread, so I cannot do the M5 portions yet because I'm still waiting on my M505. So that the M5 is the screw size, the 05 is the thread pitch. So I've got an M305, but the M505 I do not have at the moment. So we will have to wait on those until my parts come in, which should be here by next week. Most sets will not come with the fine thread, which is why I purchased one from Kris. It's in the package. It's waiting. It was waiting for the linear wire sets to come in. Hey, welcome on in, Poity. And I believe Kris said that those were coming in this week or yesterday or today. So I'm hoping to have those in by next stream, which we would probably need by then. Probably be able to still tap it later on. Yeah, the notes are called out better. Yep. So what we're going to need is we've got our M3 tap. And I am using a Pittsburgh Tools set from Harbor Freight. There's an inexpensive tap and die set, but any tap and die set would work. But once again, most of them aren't going to come with the fine threads for the bigger size bolts. So just know that you may have to buy some of these, and KB3D does sell them. So the other thing is just the spacing a bit. So like this piece is showing the diagram, and then this piece is talking about those rails. And then we say locate the point, or locate this print and start this. So there needs to be a gap here, or maybe this piece needs to be underneath something. It's just the gapping of the words in the pictures. They need to be defined steps, so defined a little bit better. So those are going to be some critiques that I will make and provide notes. I need to write the notes that I have up so far and send them over to you on Discord. So Poity or somebody or me or whomever can make the updates to the manual. And thank you for the follow, Andy Piper. Welcome on in. So once again, we're going to be looking at the part drawing and then finding the right holes. And these are going to be just like we're going to use some locking M3 set screws to lock in and hold some shafts here. So just going to use our M3.05 fine thread tap here, and we're going to tap this hole. And once again, the first part of your tap is a chamfered end, and it's not really threading anything. So when you do this, you'll want to see that my tap, you can probably see my tap starting to come through the hole there. Go ahead and thread as far in as you can. Make sure that you've fully threaded that hole. Just don't go through and damage the other side. So there, I'm pretty much fully through the hole with my tap. Now I'm going to back this out. So that's how you want to tap those holes to make sure that you're fully threading all the way through those small holes. Okay, sounds good. Thanks, KB3D. Thanks, Kris. So one done, set off to the side. The next one, once again, we're looking at making sure that we have the right part. Some parts do have a label on them. These finished prints don't. It would be cool if we had some type of labeling on the actual part in a position that's going to be covered up, of course. So once again, this one, we're going to be doing the tapped hole here. We're going to go through and tap that fully through the M5 hole to verify that we've got threading all the way through that M3 hole. Yes, slow internet does suck. Now we're going to locate the the y-axis bracket. And so we're showing the view kind of face on. Might be better to kind of show a view like this versus like this. Because here you're still going to see that hole, but being able to show it something like this where you see more of the part might help. Just an angle on these views. Because I was having a hard time looking at this, trying to figure out which bag of parts was which because I didn't label a bag of parts. But that would be a little bit better to show. Like this one is the front bracket because it's got a spot for heat set. And the back bracket is going to have the offset here without the hole. The other thing is make sure that hopefully you've got room to get that tap in there. Hopefully you've got a longer thread tap. You'll have to use some tension to get there. This was a little bit harder to do my taps. So on all the other parts that I've tapped, the print has been printing this way. So it's more of a hole like this. In this case, the part's printed like this. So you'll see that the holes have um, the perimeters on it. So these are a little bit harder to get the tap started. But once you get it started, you should tap just fine. Just trying to get the holes started a little bit harder. Timmy is growing like a weed. I bet puppies are just like babies. They grow so fast. And their like attitudes and everything change so quickly. And once again, all the parts that you see me using are polycarbonate carbon fiber, and they've been very stiff and rigid, and they take threading very, very well. So far, all of those parts are done. Those are the M3 tapping. Return to the Y-axis printed bottom. Nope. Y-axis printed bottom. And we would tap this hole with M5 0.5 threads. Once again, I don't have a tap of that size, so I cannot do that yet. According to her shot record, she's a pit bull breed. Not a purebred though, is she? Not that that's bad. I'm just saying she doesn't look like a purebred pit. Then we're going to go to this printed part, and I thought that was a heat set. That's not a heat set. This is actually going to be threaded as well. Once again, there's two places that I won't be able to thread on here because I don't have the right thread size. But I'm assuming we're going to be using set screws in there. So regardless, we should be able to thread those with whatever is supposed to go into them. Now we're going to gather 4 M5 by 35 linear shafts. We're going to put our tap away. And if we still have appropriate access, when I get my tap, we will tap those parts appropriately. In slow and steady build, keeping organization in mind is definitely a plus when you're doing a build this complicated. So here's our M5 by 35s. It says we need 4, and there are 4 in the package, so that's good. Also, so some packaging suggestions, Kris. You've got a package here of all linear shafts. And this is all M4 and M5 linear shafts, but those M3 linear shafts, and I think the M2s as well, came in the vials. Um, I think just putting these in bags and throwing them in with the rest of the linear shafts would be better and easier. Because I said, oh, linear shafts, I went here. And then these were in the, I think these were in the BlackBox motion kit, possibly. Either that or I put them there, one of the two. Um, so I think if you have all of the linear shafts, like magnets, I think these are 2x3. Yeah, these are magnets. Magnets are one thing, but if you put all the shafts in baggies and put them all the shafts in one place, probably be easier. So that will be another recommendation. And these lids are great. Luckily, when I finally got this lid to pop off, the small tiny M3 by 8 shafts did not leave the table, because that would have been fun looking for them. Just going to call that part out as well. These tubes are great, but trying to, having small parts and these types of stoppers are fun. We'll just leave it at that. Okay, so we need our linear shafts, 2 GT2 smooth idler pulleys. There's our idlers, smooth 9 belt 5mm bore smooth idlers. We're going to need 2 9mm belt 5mm bore GT2 22. We're going to slide a smooth idler onto one of the linear shafts. And if it feels like it's too tight, try it from the other end. And if it's still too tight, then we'll sand a little bit. Not too bad. Pulley should go on the shaft with some resistance, but not excessive force. Hey, shenanigans, do not pound your pulleys on or off the shaft. Just saying. You can work harden and peen over the ends. It can also cause flat spots on the bearing balls and cause issues with the bearing life. Yeah. This type of damage will cause bearing to experience resisting during use that results in heat buildup of the bearing, shortening the bearing life, and vibration that can cause travel through the belts and ultimately into your prints. Repeat this for a GT2 for the other GT2 smooth idlers. So we're gonna run 2 of our idlers onto the bearing or onto the shafts. These are pretty good tolerance. current going on and they got stuck. Great. Some of these are just going to be way too tight. Oh, darn it. This is just a punch, and I'm using it just to try and push the shaft back out so I can push straight on the shaft and in the center point, not trying to peen it over. But a couple of these shafts, I'm going to have to do a little bit of sanding on. And I have some fine sandpaper here. I can't tell if it's 2000 grit or not, but it's also been used a little bit. So it's a little worn. So we'll call it 2000 grit. We're just going to chuck one into our shaft, into our drill. You've seen me do this before. Take your sandpaper, put it on the edge, hold it fairly tight, and just give it a go. Didn't take much for these, because you still want them to be a good friction fit. My Nexus, how's it going? You're going to start building the switch wire while you lurk. Okay. Yeah, you just want it working. I get that. And as you see, I'm not doing a huge amount on these. I'm just going to go a little bit at a time and check the fit, because it doesn't need much for these to be able to slip on. Yeah, definitely take your time, enjoy the build. Don't don't rush through it. You know, these builds take longer when we're doing them on stream, but it also means that we're double and triple checking our directions so that we don't do anything stupid ourselves, because we go through and we go, oh, I've done this millions of times before. This is pretty simple. And then we tend to get caught up on the easy things that we shouldn't have, like trying to shove a bearing on and not checking, and then we bind a bearing. So we've got both of our smooth bearings and both of our um, tooth bearings ready to go. Got them on our shafts. They're not, I don't know if we're fully seated to the appropriate depth yet, but we kind of followed the guidance that we had there. Now we're going to install one of the smooth idler pulleys on the Y bracket rear bottom. So Y bracket rear bottom, and one that's got a lip on it. And this is a smooth pulley. We're going to take that and put it down in that M5. And if it's too tight, no worries. We'll ream our part here with our M5 reamer. And once again, reamers give you properly sized, perfectly round holes. So that's why we use reamers versus drills for these things. And once again, if you don't have a reaming set, well, KB3D Kris can hook you up. Doesn't take much to clean these up. Do the other M5. While we're at it, we'll go ahead and do all of our M5 parts. Should say all of our M5 holes. But do not spoil us with doing things right. Yes, I know I'm not Steve Builds, and Steve Builds does things with exceeding precision. So when I go to do the Milo build, we're going to have to be a little more anal and a little more precise in our working. Get all these shavings up there. So once again, here's our part. We're going to need our smooth bearing. Goes in there, and we want to make sure that it at least comes down and bottoms out on the part. Okay. So that one's done. That side's done. Now we're going to need one of the tooth pulleys on the other side. Same thing, except we're going to put it the other way with the long part of the shaft coming down. And I do want to point out, you'll notice that there's little printed in like washers here. So just things to note. Once again, long part of the shaft goes in and down to the bottom of the printed part. And then I'm going to push on the bearing to seat the bearing down fully against said printed washers. So both these are down even. Actually, that's not down even yet. Now it's down even. So there we go. Now we're going to press the Y axis bracket rear top. So you'll notice that it's one of these longer brackets that sticks out. And we want the one that when it goes on, it's got the L shape to the right, not the L shape to the left. It doesn't have the, and the one that doesn't have the M5 set. So we want this one, not this one. And so this is going to sit right on top and line up with our our shafts. We're just setting it down, getting our shafts lined up, and pushing it down flush. And everything locks in very nicely. We're going to locate the two Y-axis bracket linear shaft installation. Okay. So I'm assuming it's these. I don't know why I had so many printed out other than I might have just printed a bunch of them, did a bunch of extras. What are we going to use these for? So these are installation tools. So they should be the PLA printed tools. Place one tool in the linear shaft recess of the top bracket assembly. Okay, so we're going to place one at the top, like that. Place the other tool in the recess on the bottom bracket. Okay, so all we're doing is we're using these to properly align the shafts in the hole. And it says to put it in your hand vise. Well, there's my hand vise. Yeah, all we're trying to do is just make sure that it's centered in the hole and we have a decent amount. That's what we do. I could use my Nipix. Um, that would work as well, but we're just using it to center the shaft, and we'll do it on the other one as well. And in fact, we're going to do that now just because. Why not? I have to use my Nipix on that one. Use the Nipix. Proper hand vise would be something that does not have tooth jaws, whether that's a pair of Nipix or an actual vise. And just make sure that it does not have tooth jaws on it. So they're centered, give it a squeeze. And now that one is pushed through and centered. Both of our things are spinning fine, free. So now we're going to do a M3 set screw. An M3 by 5 set screw into the smooth side tap. And our set screws. And we do not use any Yes, Steve likes to build. That is true. And Steve does some unbuilding every once in a while. Normally because he's unbuilding something to rebuild it. Like his did a V0 rebuild recently. It was 0.2. Okay. And once again, normally we say set screws, use Loctite. Do not use Loctite on these because you're going into printed parts. Um, there were references in some sections of the manual in section 3 that told us to use Loctite on our set screws that we're using like this. Do not, regardless of whether or not you're um, like I use polycarbonate, carbon fiber, so it should be resistant to chemicals, but no reason to chance it. Now, remove the hand vise linear rail, installation tool, move the linear installation tools to the other side, clamp it, then use your hand vise, and then use another set screw. Once again, you're running these until you feel them, um, until you feel the change in tension, which means you're up against that shaft, and then give maybe another eighth and then stop. You do not want to strip the threads of these because then you're reprinting some parts and some uh, expensive filament. And now it looks like we're going to be installing this on our end rail. So before I do that, we get some things done real fast. Move these over here. Basically, I'm getting ready to clean my, get all the shavings off of this before we move on. Garbage cans so that they're out of the way. We're not getting shavings all over everything. Um, then I'm going to verify, is this a centered piece, Kris? Like that 56.5, does that actually center it on the rail or is it off to one side? Where did that piece go? Off to Yes, that puts it slightly off to one side. So this is pressed up against the end and that linear rail is pressed up. And then this way there's a slight gap. Um, so that's what I mean by there's still a slight gap there. And what you're going to see me do is undo this, scoot it just a bit, because my LDO's upside down now if I do it the other way. So yes, I am going to be slightly anal. Means I also need my other 3 blocks that I tossed in here. Once again, we're just snugging it down, making sure that everything is nice and tight, and then we'll come back and we'll apply a little bit of a Ugga Dugga to it. We don't want to Ugga Dugga it too much because once again, we are, working with a 10 by 20. And if we apply too much torque to these, we will deform the 10 by 20 profile, and that would just be bad. Yeah, Steve's pretty precise and Steve's pretty chill. Right? I know he's posted some pictures on Twitter, I believe, but he does have some on our Discord server. So if you're part of the Digital Dragon Discord server, there should be pictures of Kimmy, I believe, in the general channel. I think. I'm glad that that me and Zombie provide some good information and some, for the updates and stuff that you need, Build Overbot. That's great. That is the whole purpose of this channel. I'm going to be building regardless of whether I'm doing it on channel or not. But the fact that I can build on channel and people are getting value out of it, that means the world to me. Because if I wasn't providing any value, there would be no sense in me doing this. I mean, once again, I'd still be building. It's just there'd be no need to stream if people aren't getting any value. Okay, so we're going to be working on the left side here. I'll kind of go this way. So we're going to put 3 M3 by 20 or 2020 M3 T-nuts in. All 3 holes are going to be facing the linear rail. And it looks like 2 of them are going to be snugged up pretty close to that linear rail. And then the last one's going to be pretty close to the end here. Okay. We're going to slide that assembled Y bracket, line up the holes with the T-nuts. I'm going to do 2 M4 by okay. Yeah, let's not use the M3 T-nuts because that would not work with the need for M4 hardware. So let's read a little bit. Like I said, this is why I do this, is because, oh, that looks like M3 T-nuts. Yep, we're using M3s and M4s on this build, so make sure you're using the right, well, M3s and 4s and 5s and M2s. But T-nut wise, we're using M3 and M4 pretty much exclusively. If you've got an M5 T-nut, it's wrong. We found that out already. But I think Kris has figured out his stock. I think he said that about half of the M4 80 or the 44, which is the slot 8 peanuts. That about half of the ones that he had received were M5 instead of M4s. So if you've got a kit on order, or if you were one of the few that got the initial beta set or batch 1 kits, check your Series 80, so your the bigger size M4s, and make sure, take an M4 and run it through and make sure that they're all good. And if you have any that are bad, that are M5 size, just let Kris know how many were bad, and he'll get them swapped out for you. So we're going to need M4 by 10s. And once again, your top panel, this is the top side that's got all your T-nuts on it, and then the bottom side has all of your different size nuts and bolts. So just go through here, find the one that you need, and you go flathead, all the flatheads in one side, and then you'll start into the socket heads here, and you'll go back to the smallest size, and it always works in size order. So M4 by 10s. Slide this on. Get our M4 by 10s. Use the right size socket heads. Driver always works better that way. I'm assuming that this is, from the looks of it, it's pushed all the way to the edge or all the way up against the rail. It does say to fully tighten these, so once again, put a little bit, but remember you're on a 10 by 20 profile. So don't crank too hard. And then the other one's going to be an M4 by 30 button head. So all of our socket and flat heads are at the bottom. Our M4 by 30 button heads are on the top deck of our hardware kit. Of course, button heads are always one size smaller on the head. And we're not fully lined up there. And the other thing to be cognizant of is this button head is splitting a seam. So once again, get it tight, but be careful we don't deform the 10 by 20 in here. And also, I mean, you've already got a seam there. We don't want to cause any damage. Just be cognizant. Tight, but do not over tight. Okay, so we're getting ready to do the other one. So we're going to take our other lower bracket, This one has the 5 millimeter shaft here that's going to be used to tighten it. And we're going to go into this side. Clean out any filament shards that were still left in there from the tapping procedure. And on this side, we're going to do the smooth bearing and put the long shaft down. Now what I'm going to do here, because I realize now what the next procedure is, I'm going to put one of my printed caps in here. So that when I push this down, I don't push the shaft too far down, but I'll get it still to where it needs to be. Same thing when I go to the other side. Because here we're going to put the tooth pulley with the shorter end into the hole or into the shaft. And let me clean out any plastic that was left from the reaming procedure. I'm going to line this up on my tool like we did the other one. Stick the shaft in there, push it down against the tool. Make sure it's seated against that tool piece and the printed bottom there. So that should be in aligned. Both of these should now be in alignment as far as center alignment in these parts. Be on the safe side, when we go to put the top on, I'm going to put both of these tools back in place. We're going to take our top part, smooth bearing on the right side, the opening, the 5 millimeter threaded insert, and then the tooth idler on this side. We're going to line that up with the shaft. Push it down on there. And those should come right to the top of these little countersunk areas, to the bottom of the countersinks, and that's good. So we don't need to use the tools to press everything in before we do our M3s. We're going to add our M3 by 5 inserts here, or inserts, our M3 by 5 set screws. We use our 1.5 millimeter driver for these. And once again, you don't want to strip the plastic, and we are threading into plastic. So run your set screw in until you feel the tension change, and then do like another 1/8 to a quarter turn, and that's it. Bearings should still be moving freely, and they are. Sweet. Now I believe we're going to do your set screw. Awesome. Remove the hand vise and in the linear rail installation tool. Install a M5 magnet set screw into the location designated below. An M5 magnet set screw. Hey, Chris, if you're there, I'm gonna phone a friend here. Where would I find an M5 magnet set screw? Yeah, and I'm glad I can keep you entertained as well, Hybrid Robotic. Um, because it's definitely none of the set screws that I have in here are magnetized. Got some M5 by 12 set screws, but I don't have anything that looks like a magnetic set screw. Are they possibly, nope, because the black stops are just the Hall effects and no screws in there. Are you out there, Chris? Chris, are you out there? I don't have anything that looks like. Give me a second. I'm going to scroll up. We're at page 31. Scroll up to part section. I'm not seeing it in the list of items down here either. Two heat sets, three heat sets. Yeah, I'm not seeing these parts. One's going to go in here. The other one's going to go on this. One of these would definitely be easy to get to. The other one would be a little more difficult to get to, possibly to install and install straight. But as we continue to go further, but I don't see anything that says a magnet set screw. And I don't see anything in the bomb. It's, oh, and I'm sorry, shenanigans. You were asking about the tool heads. I plan on putting 4 tool heads on here. 3 of them are going to be Revo high flow heater cores with currently 0.6 obsidian nozzles. Though I noticed Kris has finally got some 0.6 high flow nozzles. And then the 4th tool head is going to be a E3D V6 and a standard V6. So it's going to have a titanium heat break with a nickel plated copper block with a probably the high, like a 60 watt heater in it. And it'll have a gamma slice works, or excuse me, a slice engineering gamma 0.6 hardened steel nozzle. So what I'm going to do is pull my 10 millimeter balls back out here and put them back in this package. Give me my 8 millimeter G10 balls. Put them back in my FDM tool package because that epoxy should be set now. Put this aside. So yeah, I think I've hit my first huge stopping block here as far as what we mean by um, magnetic set screws. I can't tell if these are just standard set screws or what have you. So there's our plate with our 5 M3x8s epoxied in. That's good enough to the side. Yeah, I'm kind of stymied right now here. I'm not hearing or seeing KB3D respond. We'll go ahead and install this for now. But we're definitely going to have to circle back on this one. Hopefully, before we get too much further, we'll get Kris back on here. I know he's a busy man. They're in the process of moving facilities still. But yeah, we're going to need to phone home on this one. So we're going to do our 3 M4s set screws. Once again, 2 almost all the way to the end here. 1 at the other end. Put that in place. We'll need a couple of M4 by 10s. Now, like I said, the only set screws I have are that are M5 size or M5 by 12 set screws. Making sure that this is pushed all the way in against our linear rail. Fully tighten this. Once again, don't over tighten these so we don't damage our rails. Use our other small one to get this last one lined up. And we need an M3 by 30 socket head cap screw. Button head cap screw to go on the top. And now we're going to be installing the linear rail in the system. And once we do that, getting to these set screws, these magnetic set screw locations are going to start getting exceedingly hard. So give me 1 second. I'm going to text Kris real fast because he's not responding. So hopefully if I text him, he might get this. Five. See if he gets that. Um, we'll hope. We will hope. I thought I had his phone number, but apparently I don't. I just have to see what we can get going here. It's the only, like I said, the only M5 screws I have are set screws, and like I've got, or I'm sorry, the only M5 set screws I have are M5 by 12 set screws. I have nothing that seems magnetic. I don't even know if these are themselves are magnetic. They have to be magnetic because it's going to be the end stop. This is triggering the end stop. And these don't look like they would be magnetic in and of themselves. So yeah, we're got to be a specialty item. All right, give me 1 second here to dig through the box. I think there's one other box in here that may have some miscellaneous stuff in it. Let's check that out. Thanks for alert shenanigans. We're digging through a lot of boxes, so these are hinges or CFE water blocks. No, not in this box. This was listed as miscellaneous other black box parts. Um, this is the other electronics piece. Fuses, bushings, fan, keystone jack, pull boards. Not in the electronics box either. I would assume that it would not be in the duet boxes. Yeah, so I'm kind of at a loss now of what could be being called out here with the M5 magnetic screws. Um, we're probably going to paint ourselves into a corner, but we'll keep going. Feel more and more like I'm going to paint myself in a corner doing that. First cup of coffee down. Good thing we got a second and some protein shake. So position the assembled gantry inside the machine. And then we're going to install it. So we're going to take this stuff, move it off so that we have room to put the machine up here. Put away some of our tools. By the way, I know I talked about these before, but these Nippics are very, very nice. Smooth jaw, there's 3 different sizes in the box. And this is the kit that KB3D sent me for Christmas. So apparently he knew I was going to need some smooth jaw pliers for the Blackbox build and made sure I had them. The Blackbox is going to take up a big chunk of the table here. So let me, like I said, get some things put away, make room to put Blackbox up here. Set this over on my stool. Throw printed plastic parts everywhere, because why not? And Blackbox, which was being used as a horizontal surface, now needs to come up on the table. And the easiest way will be to set it upside down on the table, because that will be the easiest way to install our linear rail rather than trying to hold it up and install it from underneath. So we're going to have to flip this over, but we got to be careful because our bed and bed system is still pretty loose in here, I think. It'll move around a bit. So we got to be careful that, is this going to move on its own? Somewhat. So we'll be careful as we flip this over so that we don't run our bed off. But once again, I think having it here and being able to have ready access will be good. Okay. We'll have access to our blocks here. And position the gantry inside the machine frame with the linear rail facing the left side of the machine. Remove the blue painter's tape from the y-axis if previously installed, and line up the front y-axis bracket of the gantry secure with 3 M3 fender washers and M3 by 40 socket head cap screw. So looking at this, we're going to position the printer so that it matches. So this would be our the back side with the let me think through this. So our linear rail will be facing this piece here. So our linear rail of our gantry when we go to install this, we'll be facing this, which is the left side. Normally, I'll say trident configuration. This would be the rear. So it's going to go on there like this. Now, here he is. Yes. So the um our tooth idler, looking from your camera view, is in the back, and our smooth idler is in the front. And I'm doing that by looking at this picture. So here's our vertical center linear rail in the back. Our gantry is facing that center rail, or our gantry linear rail is facing this way. And our pulley is, no, we're looking at this from underneath. Using myself. Yeah, so they're looking at this side. Yeah, so this would be the side that they're talking about, is this side. I don't think it's going to matter. We're running M3x40s into both sides. I'm just trying to make it, get the visual for everybody. So we need our M3 fender washers and some M3x40. Socket head cap screws. Fender washers and M3x40 socket head cap screws. Oh, and hey, Winsing, how's it going? Sorry about that. We'll need 3 for one side, 3 for the other. Yeah, and because they're showing you is doing this with the printer flipped upright, that's why it took me a minute just to get my visual 3D parameters going here. On which side was which? Yeah, we're good. So, 3x40 fender washer, and now comes the hard part of trying to line up. Going for M3x40 fender washer, or M3x40 fender washers. There's just a couple of millimeters that are visible that are going to be digging in, and we're talking like a couple of threads, not much. So There's those three. I'm going to just walk around to the other side to do these other three rather than trying to turn the printer. And with one side locked in, this side is way off and highly elevated. It was interesting. This seems like it's going to be off. So we may need to not crank down on these just yet. We may wind up needing to undo our bolts up front here to let things slide a little bit. And by slide a little bit, I'm talking we're like a millimeter or two possibly out of alignment. I want to make sure that I am not skewed either. So slide the trucks back, get these lined up. That's what I do is just get my trucks lined up. And like I said, we're about a millimeter off the end or off the rail on one side now. We could try and center this cross member, but really 1 millimeter, we're good. That going to do the outside, inside. Outside, inside. The remaining one on each side. And make sure to lock this side back down. Once again, do not crank for days on these because you will deform your rail. And we do not need a deformed rail. Now we get to start playing with the XY motors. Not there. Fender washers go back in this set. All right. So what I'm going to do is I'm going to take Blackbox and set it back down on the ground. Oof. That's not moving at all. So let's do just making sure that we've got good movement because we're really good there, but here we're still a little bit tight. Now's the time to make sure that you got good movement. Last thing you want is for this to be kinked and you're not getting good movement along the axis. Moving freely. What I'm finding is we don't want to put much tension on these screws whatsoever, because if we do, it starts getting harder and harder to run the axis. So if I loosen these up, it moves on the axis just fine. But if I crank down on those a lot, then it gets real tight, which means we're squishing the balls in the races. And by coming back to the stops, I make sure that I am perpendicular to my rails. And that's why I loosened them up and was running it up and down the rails, is to make sure that I keep that perpendicular. And if I start binding more or less at any one point, It could be that the rails themselves are not fully parallel, in which case we would loosen one of the rails, run it, and then retighten the rail so that it's matched perfectly with the other rail. But I got the same amount of tension. So, hey K2, how's it going? One song. Yeah, I think we're having a good day so far. We've hit one snag right now, which is it was calling out for some M5 magnetic set screws. Darn it. And I have no idea where those are. I haven't been able to find them. So I've got to call into Kris to see if maybe, just maybe, I'm missing a part. Because yeah. Okay, so yeah, that's good. We're going to work on some heat set inserts. So we're going to take our printer and set it down on the ground. And I cannot express to you how heavy this printer is getting already. We're going to dig out some of our printed parts because we're going to need the motor brackets. That looks like a motor bracket. Looks like possible parts to a motor bracket. That looks like a motor. So locate the motor bracket front part and install M3 heat set inserts into a location. There's probably going to be more than one. Those over there. Move these over here out of the way. And yes, our M3 heat set insert is in there. Normally it's the one that's all blacked up, but I went and cleaned it some yesterday. So I had to look at it. And we need our M3 heat set insert. You're done with taxes. Awesome. I've submitted all my taxes to my CPA. Now I'm just waiting to hear back. So on our printed parts here, see which one is it showing? Showing me this piece. Okay. We're going to put a M3 heat set insert on this side. Make sure you're getting the right part. Look at the diagram or the image, and then look at your parts and make sure that you're grabbing the right part. Make sure that we're nice and flush. That one's done. locate the front part with the one that will join this piece. This part, we're going to put a heat set insert right there. Be a little more fun because we don't have much of a base to go on. There's that one. Okay, and apparently it's going to move me on. I'm assuming that we'll have some other stuff to do on these other two parts. So I'm going to scroll down through here and see what we have for heat set inserts before I put those away. Fine. It's going to take a while, so we'll move this out of the way. We'll work with this one motor, and then we'll come back for it. Just too many steps that we're going to be scrolling past that I don't want to. Okay. We're going to locate one of the NEMA 17 motors. Found it. Add that to the collection. So NEMA 17 motor. We're going to remove the 4 screws out of the bottom. And yay, these are Phillips head. Bigger one work better? These are in there with a bit of torque, so probably some torque and probably some Loctite. So it's going to help to push in when you're trying to break the bolt and unscrew it. So once again, get it lined up, push in. So push them together as you start to turn. Go slowly. That way you have less of a chance of stripping the head of the bolt. Does look like there's a little bit of Loctite on the ends of these. He says to put these aside, that we will not be reusing them. We're going to place we're doing this one. We're going to place motor bracket front part 4 CE onto the bottom of the motor and secure with 4 Den M3 by 50 socket head cap screws No, orient the motor with the electrical connector facing down. So it should be facing this gap, I believe. Not seeing it on the two faces that are shown. That would be up. So we're going to set it like this. The electrical connector down. We're going to need some M3 by 50 screws. M3 by 50. Now I'm curious because the previous ones, like I said, it's hard to tell, but they did have a little bit of Loctite on them. Like, do I put a little bit of Loctite on these or not? Didn't necessarily call it out, but we'll go without. We should be fine. I'm going to crank on these a little bit. We are going into metal at the very end of these. So okay, there we go. Now we're going to locate the installation tools. Snap it onto the shaft. And with the step in the bottom of the base. All right, sounds good, Hybrid Robotics. Take it easy, my friendo. We're going to put a GT2 pulley on. Back up here and grab our GT2 22 9mm, 5mm bore pulley. Normally do this on a paper towel so we don't lose the set screws. We're going to put some Loctite on the set screws. And holding our clip in place, lining it up on our uh, flat of our motor shaft. That tighten against the flat. And the other side. And that's done. Now we removed our printed installation tool and we're going to locate a Y-axis motor bracket front. This is an interesting little piece. That in there. Put some of the bigger parts. We got this piece. Now this printed part onto the XY motor bracket front, shown below. Motor not fit well with this insert present. That's okay, remove it. It's only required for some motor flange. Okay, so on, once again, this part, we're going to add this printed piece. And I'm making sure there's two different ones of these. It's slightly offset and it's beveled. So make sure you get the right one that fits into the beveled groove of the printed part there. Okay. Orient the printed assembly onto the NEMA 17 motor, being careful to keep the printed parts together. And that's the big opening where our wires will come out of. Got the little gap down here. And this piece with that little printed part inserted, then comes in like this. Like we said, if that printed part that we put in there interferes, we can take it back off. I'm going to test it both ways and see which way I feel it sits better. And I think in my case, this sits better without the printed ring in it. So that's good. We'll leave that ring out. See everything sitting flush. And with the orientation, this opening lines up with this big flange opening. We flip it to the other side, you'll see that the two grooves line up, and it's a little bit proud of the motor. That's how that's going to line up. We use M3x45s on this end. So M3 by 45. I'm going to say, so something is off here. Did I miss something else? Put this piece on. Okay, then we add another piece. That would be it. Like there's just way too much. Hey, my buddy Vegas, thank you. Thank you for following. So we need to add this piece on top of this piece as well. So it's got just the slightest divot for our flange to run proud. We need to make sure that our parts line up. There we go. So there's our full motor belt, not belt, motor assembly. Okay, that's one. And now it wants us to install it in the frame. It'll have me build both first and then install the motor. Maybe not. This harder way where we have to keep putting the printer up and then down, up and then down. I would suggest to Kris, and I will add this in my notes, that just from a ordering, like order of operations standpoint, that we build both motors, then install both motors on the printer, as that will just reduce the number of times we have to move the printer around if we don't have this big 4 foot by 4 foot loving workspace. These screws, once again, are not needed anymore. We can toss them. We can hold on to them. Your dealer's choice there. Okay, and with how this is going to go, we will go ahead and flip our printer back up into a proper orientation. Go. Um, okay. And we're going to front left. So this is I hate this. Front left extrusion of the frame is shown. Motor here, motor. It's going to go on this side, right? We have an extrusion at the top. This is and here's our linear rail, linear rail. These right here, so front left, kind of in the back side of that extrusion. Just trying to visualize here. You is sorry, looking at it inside the rail. Going on this side. Quasi inside out. Right. So we're looking at it kind of like this way. At the Y rail at the top, X rail over here. We're looking out at this corner. We're going on this side right here. Okay, now we've got that figured out. We need two 40 series M4 T-nuts. So these are our big M4s. We want one with the hole up and one with the hole down. Up, hole down. We're going to place the assembled Y motor with our two heat set inserts that line up here on the outer edge. We'll go in like this. And tabs at the back of the motor lining up with the roll-in T-nuts installed in the previous step. Top of the motor should be flush at the top of the extrusion. Here, the top of the motor assembly with the frame with M4 by 35 socket head cap screws. And what we're doing is we're going into the M4 hole at the bottom of this gap and the M4 that's right above the pulley. Kind of hard to see. So those are the two gaps that we're doing. What I'll try to do is get these somewhat lined up by eye. And we're looking for M4 by 35 screws. M4 by 35 socket head cap screws. I think I got them both started. I'm going to take this and push it all the way up to the top. And screw these in. Got our motor installed like this. And kind of the view that they're showing. Manual. Right in, right in at the top, right in at the bottom, which I've got both those in. Now we're going to add a couple of more brackets here. Really wish there was a better way of showing this to you. I go to that view, it's still not going to be good. Turn this 90 degrees, then I'm going to be looking at it weirdly. So we're going to use the Y-axis motor bracket. So when looking at that motor bracket, we've got two holes here. We're going to tap M3 threads into the top hole. Then we're going to locate the other part. Will be this part, and we're going to tap an M3 thread at the bottom of the bottom hole. So we're going to need our tap again. So let's grab our M3 tap. Okay, our tap's set. Hey, Daddy Wazzy, how's it going, friendo? Welcome in. We are having a blast. So once again, it is the lower of the two holes here. We're going to tap. say lower, but it's the top one. Parts oriented like this, like it's going. And on the other one, be the lower of the two holes, one that's not a through hole. One that's a through hole, but a through hole into the M5 hole that we're going to have another pulley in. Okay. And because I don't want to keep getting my taps in and out, in and out, in and out, I'm going to grab the other two parts and tap those as well, just so they're done. Hey, Pete, how's it going, friend? Welcome on in. Welcome on in. We are having fun. We're putting together the x-axis here. Doing some tapping for some set screws. We're going to need to gather two linear shafts, more of our GT2 idler pulleys. For visuals, I'm going to set this back down. Let me tell you, this thing's getting heavier. Okay, so video is back down here. I'll open that up. Need our pulleys and our shafts again. Pulleys. All we have left are toothed idler pulleys, by the way. So grab a couple of those, and we need 5 by 30 shafts. Do 5 by 30 shafts. Okay, shaft on pulley. Nice, good fit. Shaft on pulley. I have to work on a bit. Not much, just a little bit. So we'll just tuck it up in our drill. We don't need to do the whole length. We're just going to do some of it. We're going to take some of our finer grit sandpaper that we've used over and over and over again, so it won't, it's even finer now because it's more down some. We're just going to slowly run it down the shaft. The shaft should be easier to go in now, but still a little tight. So we'll hit it again. Take your time. You still want it to be a tight fit. You don't want it to be a loose fit. I think that's going to work. It's going to be pretty tight, but it should still work. So we're going to take one of our pulleys. We're going to stick it down in this part. And our M5 holes in here are fairly tight as well. So let's ream those out. Easier to do it now than later. Easier to do it now. And these are fairly uh, substantial, but be careful still. And once again, we'll go ahead and do the other two parts while we're at it. And these are carbon fiber polycarbonate parts. So sometimes a little bit harder to get the little slivers out of them, because those slivers happens to be a piece of carbon fiber. So crap, now I got to figure out which part was which. The one we're using. Grab one of our bearings down in here. We want to push the shaft down. This is obviously the one that was the tighter fit. One goes there, and then the other side is going to go on the top, and you'll notice that your holes will line up, go together. And the exterior has that conical shape, so we can use our tools to center our shafts. The other side has the bumped conical shape for a washer top. That's how you can tell the sides and the differences. You also have like interlocking nubs. They're hard to tell, but there are little dimples right there to help them interlock. That's how you can tell the difference. When they interlock, they're ugly. Now locate two of the belt tensioner shafts. So these are, we'll say, our longer shafts, alignment tools. And we're going to put these in, one on each end. And then we'll need our pliers to squish, and that will center our shaft within the printed part. You want to throw your printer away. Why do you want to do that, Hybrid Robotics? Other than it's obviously giving you fits. We got the one on the top, the one's going to go on the bottom, top, or whichever one you want to think about it. We're going to get them lined up, give it a gentle squeeze. Just like that. Now our white parts or PLA parts are nice and flush, top and bottom. They'll fall right out. And our shaft should be an equidistant down in the hole. Pulley still runs easily. And that's going to want me to install this, right? Oh, yeah. Keep it under tension and then tighten set screws. I'm not going to keep it under tension, but we will do set screws. M3x5 set screws. Yeah, we're not going to keep it under tension. I don't see a need in it. So that, then I'm like, yep, I will put it under. Remember, we're going printed part into or through a printed part with tap threads up against the shaft. We're not going to be able to apply ugga-duggas to this. So that's going to be that assembly. And guess what? It's not going to tell me to do it, but I am going to do it. I'm going to go ahead and do this other one at the same time. And that one did good by hand, so then we're just going to hold it with a little bit of compression. Put in our 2 set screws. Hold the shaft in place. What kind of printer? The parts just fall out. We've got that piece done. Once again, Nipix comes in handy. About 5 set screws back over there. Okay. Remove the printed installation tools. Already done that. Locate print XY motor access pre-tensioner tool. Pre-tensioner tool. We use the tool to set the pre-tension gap of the XY belt tensioner. Tool slips between the motor housing and the tensioner part. So that's where we're going to hold the tool when we put in the belt tensioners, which I'm assuming this is going to be our belt tensioner. Place the tensioner assembly onto the motor mount housing and secure it to the housing with 2 M3x35 button head hex screws. M3x35 button head. And for those of you following along, yes, that's right. That means we need to bring Blackbox back up onto the bench. really would be great if we prep both side parts and then just bring the printer up on the box. I mean, granted, if you are building Blackbox on, like I said, a big workbench, not a problem. But I don't have the largest workbench here. So let's bring Blackbox back up here. Ah, and I'm going to orient it in such a way, looking at that part right there. And once again, we're going to use this right here to set that pre-tension gap when we run these M3 button head screws and our tensioner bracket that we just did. Um, so the angled corners, you see how we're doing this? So the straight edge goes up against the printed part. The wonky uh, cut edge goes towards the printed part gap. So we're going to take our M3 socket head screws. All right, give me a second. You have to re-squeeze a gap here. Apparently, I had one that I didn't get squeezed all the way or enough or appropriately. The reason we need that gap, because when your button head cap screw goes in here, it's going to go right over the top, right under the bottom of that shaft. That's why we're using smaller shafts here. Shaft isn't centered right. These two are not going in. So I'm going to get this lined up here. I'm going to get these started because I'm dealing with a linear rail there. And I'll pull it back out on its screw. Well, pull it back out on its screws. Apparently, once again, easier said than done. And use our gap tool to set our gap. There's our gap using our tool. So we're just going to pre-tension this by bringing these snug. Okay, then we can pull our tension block out. This is at the initial tension spot for our belt tension. Okay. Move the pre-tensioning hole. Locate print XY axis motor bracket and install the heat set inserts. So now we're going to start working on the other motor. So we're going to pick this up and set it back down on the ground so that we can get you guys some visibility. And now everything I put over here, I need to move out of the way so that we can put the heat set tool back up here. Stealth press. Okay. So we're going to take this spot and the top hole here. I think we only put in like what, 2, 3 heat sets. The Ender 3 V3KE. I don't like the naming convention. Those are killing me. Definitely sorry that you're having issues with it. Yeah, you do not want another Creality printer. Know that. Once again, it's in the top hole up here. And this is one that's a little bit tighter because it's got the perimeter versus being printed on the side. So and just be careful when you're doing your heat set insert, you're really, really close to the edge of the printed part here. So go slow, take your time, be careful that you're not burning the edge of your printed part. You need to make sure that you get your part nice and flush. Out of the way. And then the other one's going to go on this piece right here. This is just close to an inner edge, so you got to be careful that you don't blow it out when you insert or do something. And remember, we won't need these little printed ring inserts because they will interfere with our motors. Not going to be used. I believe we're done with this. Yes. So power off. Move it out of the way so we don't burn ourselves. We're going to grab our other large NEMA 17 motor. You're thinking about selling a Prusa Mini. Why are you going to sell the Prusa Mini? Asking for a friend. Yeah, so if you've got a the standard reality it'd be like 220, 220, or 225 by 225. That's right there in the bamboo size. Um, so you want to ask, he was putting back together a Creality Ender 3 V3KE. K2 needs space for something special. What are you needing space for there, K2 Kevin? So once again, these are decent screws if you need them for anything. If you don't, you can toss them. I personally can't stand these small, tiny Phillips head screw tops. So I'm probably going to toss mine like that. I'll remove the 4 screws and we're going to install that print plate. This one. And orient the motor with the electrical facing. Yeah, I'm so confused. Does it go like this or like that? This is how I did the other one. Or at least it thing into the. Now you're gonna make me sit here and wonder if I. The good news is no, because I'd have to take it off at the top. Not damn. I may have to take that other one off and reorient it, which would be done off stream. So what we're going to do is we're going to take a quick gander right before I get too far, right? And I'm going to take a look at the CAD here just to make sure that I'm doing things. Okay. So here's my motor. and continue to root this around. So motor's this side, and this is the rear back pillar. So rear back pillar, motor would go, well, I say rear back pillar. So we're gonna have some fun. Is kind of where I'm getting at with it because I've put things in the wrong place. And I may mention that we probably want to have the CAD up so that we can look at the CAD. And then we haven't looked at the CAD yet. So let's look at the CAD now, right? Um, when we look at the CAD here, we've got the open leg, which I'm going to set towards you right now, right? So there's a couple of things I see. Open leg, open leg, open leg. So let me do this the right way. Open, open leg. Um, yeah, your open legs here. 2060s are going this way. Gantry's going this way. Right? So we got that. Um, my motors, sorry. So looking at this, bed mount, trying to figure out where my two motors are. That's a motor. There's the other motor. So my motors could be on these sides versus these sides, or maybe not. Getting confused. I'm confusing myself, I think. That's a motor. That's a pulley with an end stop. Motor there. Okay. Me and this CAD program, not design. Boom. Here we go. One motor there. One motor there. So the motors are going on each side of these rails back. Um, I'm so confused. Yeah, I am so confused because this is like showing all three linear rails on the back. Can't be. Okay, linear rail on the front. I swear, doesn't that look like the linear rail connection bracket? It looks like, okay, so this CAD is confusing as hell because it shows the motors on the backside with linear carriages on a bed, but the linear rails are at the front of the, like the bed's turned 180 degrees in this particular. Yeah, now I'm confused thoroughly. And the whole purpose is I'm trying to figure out whether my cables, which direction my cables come out is what I'm trying to figure out, right? So are my cables coming out this direction or are they coming out this direction? So we're gonna give me 1 second. I'm gonna scroll back some. Okay, so we're mounting it like this on the first motor and orient the motor with the electrical connector facing down. And my thing is I'm not seeing electrical connector here or here. So I face the electrical connector towards that opening, which means it would be facing this side of the printer. So I'll say our center rear rail. Okay. Looking at this almost looks like the cable connector right there, right here, which means it would be facing this way in towards the belted Z. It, once again, hard to see, but it looks like there's a little bit right there, which would mean this needs to be clocked 90 degrees. So I'd have to take this whole thing back off. Yeah, so I'm going to have to take this motor back off and clock this so that the pins are coming out this way. Now I'm wondering if I can get to the M4 screws still without having to take the tensioner and piece off. Make it a little bit easier. So motor piece, we're going to face these down and this to the side so that when it's mounted on this pillar, it's coming towards the inside. So there we go. That was painful. But now's the time to try and figure that out. Okay, so those four are in there and screwed in. Once again, following the orientation, motor wires are facing down. We really need some type of indication on these to help identify. Need to talk to him about that CAD because CAD is all kinds of jank. We're going to need our printed spacer. Going to go on there. We're going to slide the GT2 22 pulley on there. So we'll grab our other GT2 22 pulley out. Make sure that those grub screws don't go flying. And I will do those over here just so we can keep moving. Okay, so we've got the stack. We're going to put our pulley on. It shows it going in the same orientation. Meaning normally we'd have one flipped and one down. So it must be the difference is made up in printed parts. Or I take that back. This isn't a, is this a Core XY? Or if this is Core XY or just a Y. There we go. And we're seeing here Having some indicator here that there is a plug coming out the side would be good. We didn't need that tool. We're going to take that part, set it on there so the nubs line up. Then we're going to put on the other part, which is considerably thicker. And we are going to use M3 by 45 screws still. We're going to need 3 of these. M3 by 40. We should be able to get both screws to the other side. So do that. Do the rear left extrusion. So they both said rear left extrusion. Once again, looking at it this way, pick this up, turn it around some. So the angle that we're getting is kind of this. So you're seeing linear rail here with a stopper in it. Why that's still there. Right? So linear rail, and this is where our M4 4040 peanuts go. One goes up, one up, one down. one facing up, one facing down, and then this will get installed. So what I'll do is I'll just try and visually line up my M4 holes, make my life a little bit easier. We're going to be using M4 by 35s. Give me 1 second here. 3 by M4 by 35. Ooh, got them lined up both at the same time. So we're just going to scoot it all the way up. Right? Motor's not impeded. We've got that there. Next up, we'll put in our other tensioner block that we built. Once again, looks like the belt slides will go on the inside. So this will slide in there. This, man, that is a tight fit. But it's going to go on like that. So did this piece already. Piece, that piece. Now we're here. And we're going to use two M3 by 35 button head cap screws. And of course, we'll use our spacer block here. And that is a really tight fit. So before we do anything further, pull this down and take it off. So there's a pretty darn good chance that I just ugga these down too much. And that's what's causing that tension. Just undid that about a quarter turn each. That slides a lot easier. So once again, our piece will go in. Our M3 by 35 button head cap screws will go in. And you notice I'm not putting this on our part because if you look in there, I should be able to get to that screw. So we should be able to take the other one off without undoing the whole piece. We'll just need to turn the top and bottom 90 degree. Okay, so there's that piece, nice and tight. Too tight. Pull that out now. And we'll put this right back up and go ahead and slip this back in. Tells me I'm not lined up. Why am I not getting lined up? Okay, so now this one's good. What we need to do is undo this other side over here so that we can rotate the top and the bottom. Hoping to be able to do this as a assembly. Me? Okay. Now it should just be a matter of pulling these screws out, rotating this 90 degrees, rotating the bottom 90 degrees. Um, yeah, I don't know if Orca has incorporated those yet, but I do know that Prusa Slicers incorporated when you're cutting parts down to make them fit on the bed, they do have the various connector types. Like you could do conical connectors or dowel pin style pegs. Yeah, I'm looking forward to getting the 350 up because that will be my biggest enclosed machine. My biggest machine to date is the um, Ender 5 Plus, been converted to a 0G. And that's the one I do most of my helmets on, but it's it's open air, so it's PLA only. Bottom, which is easier to see. Okay, So I think we're there now. Now we'll have the idler corner brackets. So let's put the printer back on the floor. The idler bracket's going to go down here where there will be no linear rod or linear rails. How are we doing? It's 2:35, so we're making some decent progress. We're 83 pages in, so that's good. 83 pages in, only 90 to go. Um, XY corner bracket or tensioners. These will be our L-shaped parts. This, by the way, will be the carriage plate that goes on to that piece. So L-shaped bracket. Ooh, a little bit of stringing on the edge there. Let's clear that up. I had a couple of little blemishes on here. Um, Nothing major. You always want to check your surfaces, especially things that would be mating or have something rubbing up against them or running near them. So, got parts. So the XY belt corner bracket, looking for specific looks like this one. This is the one that we're, whoops. This is the one that we're looking at here in the diagram. So these smaller holes, big hole, small hole. Yep, this is the part we're looking at. And it's going to tell us to tap some threads. We're going to tap M3 in the top and this side hole here. So break out the tap again. That'll be another comment I'll make to Kris as far as manual goes is when dealing with certain things like parts prep, like at the very front, say, find these parts in the section, tap these parts with these threads, tap these areas with these threads, do all your heat set inserts, and just get all of that stuff out of the way so that the parts are prepped and you don't have to keep grabbing tools, putting tools away, or or you know, having so many tools out on the workbench at one time. Okay, so the top hole and then the bottom hole. Once again, these are going to be for set screws against the linear shafts to keep the linear shafts from falling out, pushing out, or shifting under load. Also, you want your bearings to go around your linear shafts, not seize on your linear shafts and rotate your linear shafts in the printed part, because that would wind up over time tearing up your printed parts and causing you other issues. That one's done. Now we're going to go into a bigger part here. And some more zits on this. So apparently on a couple of these, I think my filament was starting to get dry. Started getting some surface zit. I believe we're looking at this part. We've got a slot over here with a hole, small cutout. We're going to go into these two holes. Whoops. We're going to go into these two holes with the M3 tap. Ah, those are done. I'm assuming we're going to do the other two. Line orientation. These two holes here. Once again, I'm running my reamer all the way over just till it's about to hit the opposite wall of that 5mm hole, just so I know I've got the threads as far as I can take them, because your tap has a bit of a taper to start it, so you're not getting threads on the first portion of your tap. Why not? Because welcome in. The black box is going good. We are in the process of tapping some M3 holes, because that's what you do when you're building. These M3 holes are going to be used for set screws to lock in our M5 linear shafts for the pulleys. Getting these tapped out. We need to do some heat set inserts. An M3 variety. We'd have to get our insert machine out. Hey, thanks for the follow, Zataber. And welcome in. Welcome in. We've been working on the Blackbox build. And we're working on a couple of parts right now. And once we get these parts done, we'll be adding them to the printer itself. So you'll be able to see what that'll look like. Now, one thing I'm going to do while I'm here, because, well, history has shown me, I'm also going to ream out all of these 5mm holes. Just to be on the safe side, these are going to take 5mm shafts. So we want to make sure that they're nice and clean. And properly sized. Because once again, we have some printed tools that we're going to use to center the shafts in the printed parts themselves. And then use set screws to hold them in place. And all the printed parts here are printed in polycarbonate carbon fiber. Which tolerance-wise has been really good so far. And by reaming, we ensure that our holes are exactly 5mm. They're perfectly round. And to some degree, The holes themselves will get some polishing because of the material that we used. So our heat press is nice and warmed up. Alexa, shut off timer. And we're going into which part? This part, we're going to do 2 M3 heat set inserts on this side. And I'm going to do the same thing on the other part here with another 2 M3 heat set inserts. What you see me doing is I'm getting them pretty close to being flush, and then using the edge of my table here, which is metal, to kind of flush them up and burnish the area around it so that it's nice and flat in the printed part as well, in case there is some part of the printed part that bulged up, which could happen. So depending on the orientation that the part's printed in, so if the part was printed flat like this, then these holes would be pretty good, and I can press fit them in. Whoops, darn it. So if the part was printed like this, then the holes would be pretty close to being just a perfect fit, and that little insert aligner piece part would fit in just nicely, and it would keep it centered. Because these parts printed like this, with the number of perimeters that I did, it gets a little bit tight, and so that tolerance might be a little bit tight. And because of that, I'll have to be careful, because you'll see like these two here, this one kind of slipped down towards the perimeter, is not fully centered. I'll have to be cognizant of that when I go to pull the part together. And I'm starting to put that away. Let me make sure that there's sets, no more heat sets, release for now. I'll move this down out of the way so I don't burn myself. And we're going to need some more linear shafts. And we're going to need M5 by 50 linear shafts. M5 by 50. We need 4 of them. And there are 4 in the package. There's 4. We're going to need 4 more of our idler pulleys. We're digging through a lot of parts, that's for sure. Here's our 4 idler pulleys. And same old by now. We're going to try and slide these on. If they're too tight, flip the rod around. Still too tight. And that one needs to be sanded. That one's going in there. That one's gone in there. We'll just double check to make sure that our bearings aren't the issue. Starting to go on, but it's really, really tight. Yeah. Nope. So 2 shafts went on. 2 more shafts need to be sanded. So we're just going to take the shaft, tuck it up in our drill, and that sandpaper's seen better days. So let's grab another piece. Don't do it a lot, just do it a little bit and work your way in to where pulleys slide onto the shaft. Because they're not going to be all the way in on both sides. So pretty good fit. Hmm. Getting closer. Goodness gracious. Normally does not take this much, or hasn't yet. Okay. And I've been trying to use some worn sandpaper because it talks about using 2000 grit, and I don't have any 2000 grit, but this is requiring a little more aggression. Most we've had to go on a shaft bearing combo the entire time. All right, there we go. We were good. Um, do not slam on the pulley, that's for sure. Turn to the print Y. This one, two holes, hole, gap. One that we're seeing. We need one here with a somewhat lower pulley. And one more mid shaft and one low shaft. All right. Now we'll put the top cover on. Match our M5 holes up. Shafts. Press it down on there. The gap there. We're going to use the two smaller um, shaft pieces, or the two smaller shaft thingamabobbers. Hey, they as big as my Nipix goes, so I'm not going to be able to Nipix it. It'll be fun. What I just did was I put the printed part down at the bottom, and I'm lining up my hole in my pins, and then I'm just going to keep flipping it top to bottom and making sure I'm pushing flush on both sides, and that's going to center the pins on each side. Now, one on top, one on bottom, and then we're going to use M3x5 set screws to tighten these in place. Thank you for following Web Sand Flows. Figure these out. So these are the M3x5 set screws. And so what we're going to do, I'm just going to try and keep some pressure here. We're going to go into these holes that we cut threads on earlier. And we're just going to put in a set screw and drive it in until we feel that we've hit the shaft. Then maybe like a quarter or an eighth turn more. We're doing that top and bottom on both sides of our shafts. And what this is doing is ensuring that the shafts, one, don't fall out over time, and two, don't rotate. Because if they rotate, they could start to I'll say like polish the hole, and over time it could cause those shafts to fall out. So by doing this, we're making sure that these shafts do not come out of said printed part. There we go. One side. Now is it going to tell me to install it, or do I get to do the other side? Move the hand vise. Do it for the other. Yep, did that. Now we're going to take some M3x25 socket head cap screws. And where are we going with these? And I should have reamed these out earlier, did not. So that means I'm going to basically be screwing these in through the part. Oh yeah, the pin mod works great. Um, I did the pin mod. When was that? The Micron. I did the pin mod on, and the installation was tremendously easier. This is not going in. We're down already. Going down through this part. Normally, I would say do this before you put the parts together, but I'm not having a choice. Oh, wait a minute. I'm confused. Pins. Oh, I put the heat sets on the wrong side. That will be why things are not lining up. The heat sets were supposed to go on the thicker piece, not the thinner piece, and I put them in the thinner piece. So what I'm doing was actually hitting the backside of the heat set instead of going through into the bigger piece. Meaning heat sets weren't supposed to go in here, heat sets were supposed to go in. So we get to pull heat sets and redo heat sets, and hopefully we can pull heat sets without too much damage to the part. But I'd really like to not have to reprint here. Basically scraping that surface flush. Still very much usable. Now I need to put the parts over in this side. Let that sit for a second. We'll pull these out. Okay, full recovery made. Part back in there. Now we should be able to take our M3 by 25s. And these go right on in with no problem. Hey, Kris. Well, we did have one issue. We do have one issue. We've proceeded on, and I may have to take the X gantry back off because there was talking about. Well, I sent you a message. The M5. Hold on, we're on page 95. The M5 magnet set screw. What is that? Because I have no clue. I've got nothing that identifies as an M5 magnet set screw, and I'm at a loss. I tried looking in the FDM tool bags, nothing there, which didn't surprise me, but I have seen nothing identified anywhere as that. Okay, and can be installed after the build is done. Gotcha. Awesome. I'm assuming I'll be doing a lot of this with a L-angled wrench then, because of where they're at. But this is definitely a black box build note for myself. Section 4, page 31. That helps. I was looking for them for like 10, 15 minutes. Yeah, those are those are the parts that you would M5 tap. I don't have the M505 tap either, so once again, if I have to, I will take the rail back off, which I really don't want to. Or hopefully I'll be able to get to it with something. We'll figure it out. How about that? Bear with me one second here, folks. Clean up from my last mess. I put heat sets on the wrong side of the pulley parts, so I had to pull them out and then not drill through them, but I went through them with the reamer to clean them up. Still works. Pulley still goes together. Okay, and we were on, we say 91 or 95? It's 91, so I'm assuming 95. Oh dang, and we need the M2 by 6 shaft goes in here as well. And that's not an all the way through thing. You know what? I'll build the other one and then we'll come back and we'll dig out the M2x6 because I have a feeling they're in vials. And are they? Where are they? 3. Yeah. There's a bunch of M2x6s and they're in these little vials. I need to be careful when I open this up that it didn't go everywhere. These are great, but when they come off, shall we say, violently. Did you get the XY Gantry Joints the first try? I think so. We'll take a look at it momentarily because once I get this put together, we'll have to put it on the printer. And I got to talk to you about a couple of things too. So stick around if you can. Stick around if you can. Let me get this built real fast. Damn it. See, this is the other thing. Have us build both of these, then go put it on the printer. Or better yet, build all 4 motor mounts, or build all 2 motor mounts, build all 2 pulley brackets, then have me put the printer on the table. This is great if you've got a lot of room. Like if I've got a 4x4 work table, this works great. I don't have a 4x4 work table, so I have to keep clearing off the table so I can put other parts up on the table, so I can then build one part, put it on, bring the printer up, build the printer, then take the printer back down, build the next part, back and forth. That part's frustrating, by the way. All right, so here we go. Printer back up. So here's where we're going to go on a little aerial cruise, right? So XY joint goes on with the carriage and linear rail facing the back rear center linear rail, right? Because this is the way it showed it in the manual. We cruise back up here to the manual. We're in the manual. Come on, we can get there. Here's 2 and 5 things that we need to add in. Now, it showed both joints being flush with the linear rail. That is not the case. Okay. So once again, here's bracket. There is the 2020 with the linear rail, right? No belt showing. And the carriage facing the rear bracket. Right? We're good so far. Now, when we went to do the other side, what I had to do was there is a tiny gap here. If it was flush, it wasn't lining up. So I undid this side, made it flush up, right? One side flush, one side not. But that's okay. That could just be the linear rail cut to an incorrect length or build differences, right? No big deal. Nothing's coming off the end. Nothing's causing problems. We're still moving back and forth pretty easily. I got bump stops right here, and I lined everything up with the bump stops when I tighten things down. Do not tighten these down very much at all. At all. Right? Very very little on these screws. Otherwise, things stop working right. Now, the issue I had, right? We'll go forward a little bit in the manual. When we're installing these motors, right? You can agree that this is the Y rail, and we can agree that this is the Z linear rail. Agreed? Either I've completely screwed some things up because why? So we're kind of looking at it from this direction. So there's the Y, there's the Z linear rail, there's said motor. A little ambiguity as to which way the wires go, right? We got that figured out. We had to take this back off, lock everything 90, no big deal. So motors on the side with the linear rails, right? Linear rails have carriage blocks. Other side, no carriage blocks, right? Getting ready to make a big point here. We come back to this diagram, okay? So we're oriented, we have the bed. Which way are we at? Yeah. So here's the rear vertical, right? Bed, gantry. So this looks right. That shows a linear rail. Hey, look. So linear rails on the front. There's no carriage blocks here. These are showing carriage blocks in the back, apparently attached to the rail. This is a bit confusing. So the carriage blocks and stuff are on the wrong side of this bed, or this bed needs to be flipped 180 or something. Yeah, it's a discrepancy, I think, in these CAD models that were uploaded because the two carriages, these two side carriages, if you flip them so that they're onto the other side of the printer, then everything looks right. And people like me aren't confused, scratching their head, trying to figure out why the motors are showing up over here. It's just hard. It was just very difficult, right? So this would show all three linear rail mounts and the carriages, by the way. Carriages are just free floating in the back. So the carriages and the mounts need to be flipped 180 degrees on the Z-axis, whatever. They need to rotate around the Z-axis to the front side of the printer. Yeah, yeah. And it because I was trying to come here and look because see, here's the motor. See, that's the other thing. Motor is also something's in the wrong place. I'll just leave it at that because it shows the motors being at the back side of the printer. Well, there's no uh, linear rail back here. The linear rails are up here on the insides. So I got to ask: are the pulleys back on the back where the vertical third Z motor or Z linear rails at? Or are they on the front? Check the next guide's preview. So that would be the tool dock. So there's front trucks right there. So the front trucks are correct, and motors are on the front as well. So I think this is correct. Pulleys are in the back. Well, I say pulleys are in the back. So motors are on the side with the Z-axis linear rails. Right? Well, this being the front orientation, or excuse me, that's the right. Yeah. Okay. So looking at the printer from supposedly the right, this is the side with our trucks, and that would be the sides that have motors on them. Back around. So motor here, motor over here, and then pulleys are where pulleys are in the side that has the centered Z-axis. And it keeps throwing me off because the bed's all the way up at the top, and preferably the bed's going to be down at the bottom. So yeah, there's something jacked up in the XY axis pad that needs to be. Yeah, it's like the motors and pulleys are on the wrong side, and the trucks. So like that whole system needs to rotate 180 degrees around the center pole. Yeah, the XY is 180 out. So that was throwing me for no end of loop, and I was like, "Do I go by the manual or do I go by the CAD? Do I go manual or do I go by the CAD?" We decided to go by the manual and pray and hope. So yeah, it's section 4 of the CAD drawing is cattywampus. So section 4, 180-degree rotated. And like I said, personally, I would say build the 2 motor systems, build the 2 pulley systems, then install them on the printer. That way you can do a bunch of stuff at your desk or whatever, and then come to the printer and do everything at once rather than, okay, let me put this motor on, take everything down, build the motor, bring the printer back up, put that motor on, put the printer back down. I mean, I'm getting a workout. Don't get me wrong. I am getting a workout. But yeah, be kind to us old men. Be kind to us old men. Okay, so we just finished building this one. You want me to put the 2x6 in. Now I guess I'm going to have to grab the 2x6s and try and get them open without throwing them everywhere. Okay, well, that one came off. The one, like, was, yeah, I think everybody can agree. I was yanking and cranking trying to get that lid off. It was painful. So we've got that. Where's my Nipix? Here's my Nipix. Didn't need the big one. Go with the little one on this. Might not even need this. It might just pop right in, but take our M2, get it lined up on the hole. We're back. Yep, audio dropped out. So I do not have an M2 reamer, so I did have to use an M2 drill just ever so slightly, and I did it by hand to kind of open the front lip up of this hole. We got that super fiddly M2 pin lined up. We're going to use our flat face jaws to hopefully set it down. Hopefully set it down in the part. Get it fully seated. We'll go one more. Because it's not a full depth hole. We want it fully seated in that hole so it just sticks up. Assuming this is going to be for some type of in-stop pin or indicator for a Hall effect sensor or something. While I have these out, I'm going to go ahead and do that on the other side. Oh, they're not needed on the other side? Well, I guess not. Even better. Even better. So that means I can put the other fiddly, small, tiny thing back in its container. Yeah, because if these hit the ground, they're lost. They're not coming back. Put the Knipex back. Okay. Let's see about putting this on the printer. And it looks like, once again, we're looking at this obtuse angle here. Here's our gantry. Here's our belts and the Z vertical axis. We're going to go into this side. We're going to need two M4 40 series. So these are our bigger ones. Okay, good. Good, good, good. And one up, one down. Yeah. All right, I'm gonna have to turn this around. Oh, one there, one down here. Okay, I have to set this on its side. Okay, keep an eye on your gantry. Stoppers in. Got a natural stopper in the back now. Get some stoppers in the front. Last thing you want is for your gantry to fall down and off off the rail. So we get these on. And we're going to use an additional two on the other side corner of the same extrusion. So two here and then two in the back. Also M4s. Same orientation. Sure. Guide must also be fundamentally wrong. Easy fix though. A little. Now you say easy fix. Are you saying that this bar just needs to be flipped 180 degrees so that the LDO motors or the gantry needs to face the belt, not the rear Z-axis screw? If you're saying it's easy fix and the whole, yeah, that would suck. That means these would come off. Yeah. Okay, yeah. So take these three off and flip this around. That's easy. Okay, so we got these four in there. Need a black stop mount. It looks like this part. And we're going to put an M3 heat set smaller hole. You're going to make me make a comment, Kris. Like maybe at the beginning of if we can rearrange the manual. So at the beginning of each section, it says, lay out your parts. Go through and do M3 tapping, M5 tapping, heat set inserts, and get all that. That would save a lot of hassle for people that may or may not have a butt ton of space. So before I go and do the black stop, we're going to set this up on its lid. And we'll flip this around. You're saying it goes on there like this. Once again, gantry facing with the carriage face facing the belt, and the backside, the 1020 extrusion faces the vertical z-axis centered in the backside, whatever you want to call it. Yes, build subassembly, install subassembly. But I would say build all subassemblies, then put it on the printer. Get all your subassemblies built, then put it on printer. Okay. Um, let's see if we can just move a minimum of things around. That we can put our heat press back up here. Self press, heat press. Plug in. On. M3. All right, guys, I'm not going to move the printer out of the way so you can see me put this heat set insert in. I think you've watched me do a few heat set inserts over the time. Set. Place the front corner bracket. Let's see if we can get back to the front corner bracket. Ugh. Boy, front corner bracket. Printed assembly. Pulleys in line with gantry, in line with motor. We'll go like that. I'm probably going to rotate this. Yeah, rotate. I don't know what I'm going to do. I'm going to have to figure out how to line all the. So M4x20s on the left side. 4x25. M4x20s. Two of those. 25. We'll figure the other one out in a second. 4 by 20. One and 4 by 20 That's 2 and 4 by 20s. Top and 4 by 25 goes in here. Right, those sharing. Oh yeah, imagine building a 500 rat rig. Exactly. I would definitely have to get a different booth or a different table. Like building Milo on here is going to be fun. And hey, note the hole. There's a hole there. Note the index hole location on the back of the print, XY black stock mount. Let me guess, that's a 2 millimeter hole that's going to go on a peg. This will fit into the pin of the corner bracket. Why, yes, it will. We will lock that out. Line that up with the pin. Push it on the pin. We'll line this up. Then we're going to throw an M4 by 30. In this last hole. Come on. Now that I've got all 4 screws started, I'm going to move it all the way up. This one I can't get to with that. I got to use a ball head driver. Do that or get my hands on some stubby drivers. Well, I'm not sure if I'm getting Guide 4 done all in one day. We may still break it up and do, yeah, because it's 4 o'clock, so we've been going for 6 hours. We'll probably get the other pulley and then stop before we do belting, and we'll do belting on another stream. And now we need to take a black stop Yeah, black stop. What do I do with the black stops? Not in there. Oh, yeah, we're 6 hours in. We started at 10 a.m. It's now 4 p.m. So we've been going for 6 hours, and we're going to stop just because, well, I need to relax. I need to also possibly do some other things around the house. No, I don't. I'm going to go get something. Okay, so we have our black stop, and they're literally called focus, focus, black stop. Anyhow, what do they call black stop if I could get it to focus? And how are we mounting this? An M3/8 socket head cap screw. Okay. Grab an M3/8. And once again, this is going to be one of the words. Words are hard sometimes. It's going to be one of our end stops. We're just going to mount it in the full down position. We'll adjust as we need to, or if we need. And you are tightening down a PCB. Do not crush it. Yeah, time for coffee and couch. Exactly. I still need to. I guess I'm going to pay and rent it because I missed out on being able to watch it on Netflix. But I want to watch the original or the first part of Doom before going to the theater and watching the second part. So, oh hey, now we're going to build the other one. So let's take the printer back down off the print table because it's not getting heavy yet. And that was a spool holder. It got knocked off, so we're good. Okay, so we're going to take these parts. You remember these parts, right? These are the parts we did like 40 minutes ago. Kidding. All right, we got our orientation right. We need one of our idlers here, and let me guess, the other idler is going to go there. And what we're going to do to try and save ourselves some time, we're going to take one of our little conical parts that we would use to push the two halves together. Because let's be honest, um, I don't have a large well my largest set of Nippics is too small to squeeze this full stack. So I'm putting it on in that conical hole there. I'm going to push this down and seat it fully against that printed nub. Then I'm going to take and move the other hole over the top of the printed piece. Take my other one and shove it in the hole. Make sure it's fully seated and then push the pulley all the way down. Now I've got two pulleys that are seated right to the bottom of the conical area. Pretty simple, huh? Then we're going to flip the big part on here, line them holes up. So gently and make sure you're lined up right on those M5 dowel pins. Get yourself fully squished on there. I just pushed those pins out the bottom, so that sucked. We're just going to go back and push those back through. There we go. So those pieces are flush with the bottom of the conical piece. Those pieces are too. And now we're going to go through and put in our 4 set screws. How do I know this? Because we've seen this before, done this before. Look, set screws. Set screws. So we're going to take 4 of our M3x5 set screws. And by the way, folks, Kris is not giving us extra set screws, so you cannot chew on a handful of these. These are not your Haribo snacks for Blackbox. Not your Haribo snacks. Okay, squeeze. Feel it tighten, about 1/8 to 1/4 of a turn. Hey, Phoenix, you're gonna leave me before Luke hits me? I wouldn't hit you, Kris. Right, all we're doing is snugging these up so that these can't be pushed in and out. You are doing this in plastic parts. So if you ugga-dugga these too much, you're just going to strip the plastic parts, and then you're going to have to be reprinting. That's why I said I might have to go and get some food and then come back, sit down, and watch TV. Here we go. So we got the 4 set screws that are holding these, whatchamacallit, the dowel pins in. Our things are still moving, so that's good. Now we're going to need M3x25s. We're going to insert these right here and pull these 2 parts together. 325s. And just like that, 2 parts become 1. See what else? All right, so we're back to installing our nuts, but we're going to do it on the opposite side this time. So we need to put our printer back up here, figure out the orientation. This beastie's getting heavy. We're going to be going into this corner now. Two of our M4 nuts here, two on this side. Total of 4. So top one, the hole's up. Bottom one, the hole's down. Yeah. So I got caught up on Halo the other day, and I was trying to get caught up on, or I thought I was going to get caught up on Fallout because I thought it had started already, but apparently not. Those are in there. Excuse me. So we're going to need, we got those in there. We're going to need, yep. M425s on the one face and M420s on the other. Okay. So 20s go through this side, 25 through this side. So we're going to try and get this lined up, and I'm going to, I don't know what I did. I don't know. It's not going to be easy either. Got a bet in my, those two are in. I work the same magic up here. Started. I think that's what we're going to shove this all the way up and make sure it's flush up against the top. And then we're going to just tighten all these down. I think I did these first on the other side. I'm going to do these first this time. Okay, that's done. Now we're going to start working on the tool changer and XY axis belts. We're going to line the mounting holes of the Kelvin plate to the MGN 12 carriage with 4 DEN 7991 M3 by 6 flathead cap screws. So this involves us setting this back up on its main feet. Uh, and we're going to install the Kelvin plate up here. Like, why is that not going back? Because there was there was a bump stop. And I sent both of them flying now. So that's great. Oh. Okay, so M3x6 flathead screws. Okay, M3x6 flathead screws. These 1.5 would be twos. And bring you all up. All right, Hybrid Robotics, take it easy, my friend. We're going to be stopping soon. I'm not going to run belts today. I'm just going to mount the plate. So what we're going to do is we're going to take our plate. Okay, and this is where we did our epoxying. Ooh, at least one of those popped out of its. I don't know if that'll impact anything. I'll have to talk to Kris afterwards. Are these started? Now, wants me to mount the motor as well. Now, it did not tell me to use any um, Loctite. However, I'm going through metal into metal, and because it's a carriage, I don't want to crank down on these. So I am going to put a little bit of Loctite on there, a couple of threads. We got another ad starting. We're in progress. Sorry about those, but they help support the channel. Okay. We're good there. Now we're going to need our other motor. Our last, we'll call them standard NEMA motor, pancake motor. And 3 more of the M3x6 flathead hex screws. And we will do the same thing here. We're going to mount these with a little bit of Loctite on them. And it said to install it with the wiring connector facing up. Okay. Hey, Britt, how's it going? Yeah, we've been going for 6.5 hours already. Um, but we've got our front motors installed. We've got our rear pulley system installed, our rear end stop. We've got our kinematic carriage, what we call this thing, the Kelvin external cooler CNC plate installed. And we just installed our motor. Now there's a print bracket we need to install 7 heat sets into. I'm going to pick this up and set it down so you guys can see what I'm doing. That's not needed anymore. Put this back over here. Grab this. These will go into the put in parts bag. Oh. We're going to be doing this part here. We need to add 7 heat sets in here at the prescribed location. Yeah, we've gotten a pretty good amount done. So the orientation is like this. Oh, I guess it helps if I actually plug it in and warm it up. Otherwise, it's going to take a long time for me to press those in. So we skip a hole, then we do 2 holes, skip another hole. Yeah, and like I said, as soon as it tells me to start messing with belt, that's when we're done for the day. I'm I'm too kind of uh, tired to start working on belt routing right. Now 2 more. Post any more dragons because that dragon is flipping awesome. I want to say that was Deathwing, right? I was watching you set up that photo shoot, and I was like, man, that thing is awesome looking. Okay, we're going to rotate and do 2 more in this little recessed cavity piece there. 2 more there. Oh, did you? Like Warhammer painting or just Warhammer lore? Okay, so we had those 7, those 2. Any more? Rotate. Now it says to rotate and install 2 M3 heat set inserts. I'm just making sure. Okay, so we're going to have to let this cool down, and then we'll have to do our other heat sets that are the M2. This is the first time we've done the M2s. Oh, it should do well in the make. I don't see why it wouldn't. Okay, that goes there. Need our M2 insert. Be the smallest one we got. We're going to take this part that has this little tab in it, and it's going to fit right into this tab piece here. Would be a pretty tight fit. Yeah, pretty tight snap fit. Get the feeling that be an M2 screw, and then there's a wire channel. I think it's good progress. Um, yep, not enough yet. That kind of hurt. Don't be impatient. These normally pull off quicker. Then again, I haven't had the AC kicking it as much. I don't even know if I've been doing this. Damn. Oh well. Guess it just means wait. Ah, yeah. A few more of the heat inserts to do. Tell that people are really here paying attention, considering the fact that I was actually trying to tighten it, and that'd be why it wasn't coming off. I would highly suggest not doing this, especially if you don't have silicone mat that you can set it on. Keep it from burning through or burning your tabletop. Or dropping on the ground and, melting your carpet. Always make your spousal unit happy. Three's off, two's on. Only burned a little bit of skin off. We're up to temp. We're going to take our little tiny M2 inserts. We're going to flip this over and we're going to get these going. And tiny inserts. Tiny insert. There's the two inserts. All of our three inserts. We've already clipped the one piece in that we needed to. It's going to tell us to do in the next step. This lip in. And now we're ready to line the bracket and the assembly to the back of the X plate and loosely secure with the M3 by 35 as shown below. Okay, this goes on the back side around the motor. Okay, move some things out of the way here. Bring the printer back up and I will turn it around when I do this so that we can see the back end of the motor assembly or the X gantry. Okay, so once again, we're at the back. We've got the motor right here. Okay, we're going to take our printed part, and it was an M3 by 35. M3 by 35 socket head cap screw. Just the one. And we're going into the hole on the left between the two heat set insert. Going to go into that hole there. Going to go around the motor and everything and line up. Plate. And loosely, so I'm just bringing it up there by finger. There's that. And there we go. That's the point where it starts talking about belts. And that's the point where we're going to call it good. So we're going to call it good. Tomas? Part of me it says like pull this back off and not have this plate because it sits proud of the top. So it's like I can't set stuff on top of it and have been. But that's our plate, and we're getting to the point where we're going to start running belts around through the front plate. And when we start doing belt, that's where I said we were going to call it quits. So we are 128 pages into 174. So we will do another stream. I do need to take a picture of kind of where we're at. In fact, let me. Got no way of really making pretty shots. But yeah, we're moving. I do need to take a shot of the one M3 by 8. And let me see if I can't turn this completely around here and I'll show you my issue. I'm going to have to talk to Kris in the community about this, but one of my rods, and it's this one here on the end. See if I can't get it set up like this. You'll see how it popped itself proud in the plate. I have a hard angle shot to find. But this end lifted up out. And it's epoxied in place now. So I'm not sure if it's going to be an issue or not. I'll talk with Kris. I mean, the rest of them are pretty good. Like this one, I think kind of bunched up some as well. I think these two right here aren't as seated as the rest of the. I'll have to talk to Kris about that and see if that'll cause me problems if I don't press it. Like I said, it's kind of hard to show, but it is sitting proud there. I have to see what I can do to fix that. Hey, thanks for the follow, Fishbach. But other than that, we're doing good. We've got the XY motors in place. We've got the rear idler brackets in place. We've got a Y end stop in place back here. We got our XY gantry installed with all the idlers and stuff. And we've got our actual X gantry installed with the motor and the first plastic shroud piece that's not fully tightened down. It's just sitting there for right now because we're going to need to start routing belts. And when we route belts, um, you know, so this lower front will line up with lower rear back. This front lines up with the rear left over here. So, yeah, good times. We're making very good progress on this build. I think for now, this is a good stopping point. We've gone for almost 7 hours, and we had to work through a few things. And good thing Kris stopped back in, so he caught some of them. But we're ready to start running belt. And I'm just kind of checking along here. Yeah, some belt. Yeah, I think that's it. I think the rest of this is all belting. Yeah, we do belt. Then we add the special gear to the gear shaft of the motor. Flange bearing at the front of the X carriage. Yeah, there's very few things that we have left to do. So with that, let's go ahead and see who we can rate out to today. Thank you so much, everybody, for being here. Does anybody have a suggestion on who to rate out to? See who I have showing up in the list. Got Biomods, Ugly Moose, Stephen Poole, Gary Show, Free Heathens on, Baker Deck, and Chris Perillo. So Asper Canuck and Thug Shells are live. Okay, why didn't Thug Shells come up? I'm following her. Guest start or huh. Okay, so do we want some sciencey or do we want some music? Oh, and we're in an ad break. So let's finish the ad break and then we will continue our chat. A few more seconds. Continue to put some things up while we're waiting. Using these parts. Okay, everybody's back. So I think I'm just going to call it, we're going to go over to Thug Shells. Haven't been over there in quite a while. And she's playing some music. I think we need to get some hype going because, I'm kind of low energy right now. So let's jump over to Thug Shells. He's out there mixing some tunes. So I think that'll be good. I'm going to go ahead and get the raid started. Thank you once again, everybody, for being here and supporting the channel with bits and subs today. We made great progress. We'll do another stream probably midweek for a short stream to do belting, and we'll keep going with doing the actual tool dock is the next section. Or wait, no, standard tool lock. Sorry. So thanks everybody for being here. Come with me as we run over to Thug Shells. Have fun, and we will see you guys next time. Bye now.